Like, that's one of those, like, universe, or not universe-ending events, but, like, civilization-ending events. We really can't do dick about that. So, but yeah, the weather. I'll wait until. Oh, first I'll wait until a meteorologist comes in here. There's a couple of them that watch the stream, and I'll ask. Mostly because it wouldn't flip instantly. There would be a period of field chaos where Earth's protection from the solar winds would be severely compromised, and that would be bad. Yeah, people would go outside and they'd get microwaved, basically. Correct me if I'm wrong, but in the 19th century, a massive solar flare that happened called the Carrington event happened. If that happened these days, that would mess up the Earth, right? Oh, no, Dunfield. Solar flares won't mess up the Earth. The Earth will be fine. It'll mess up the climate around Earth. Oh, yeah, Earth is fine. Earth's just a big rock. It's no different than Mars or anything else, right? Mars, or, well, Venus, it's just the stuff that's around it is different. Mars has nothing around it. Maybe some sand. Venus has a lot of gases around it. More gases than Earth. Gases, I mean, admittedly, those gases will kill you. Will it mess with the electronics? Like I said, Zensid, the magnetic field will catch most of it. Like 90% of it. So that 10% is the part that you have to worry about. If Earth didn't have a magnetic field and a CME came towards us, we'd be screwed. Yeah, best be getting underground. Yeah, for a pretty extended period of time. I mean, the people on Earth with all the electronics. How's your day? My day's good, Clutch. All right, let's get into space news here. Now that we're talking about it, let's do it. So, EJ's space and rocket review. That was fun. I'm enjoying building trains in Satisfactory. I'll switch this over to science and tech, and then we'll get into Kerbal after that. I'll be back in about 10:15. What about the atmosphere? Well, there's two things that's holding the atmosphere, Chloral, in place. Gravity is doing it, first and foremost. Gravity holds most of it in place. But also the magnetic field keeps the gases basically contained. See, like, that's the thing. It's not just gravity. It's both of those things. You need both of those things to live. For us to be able to be sustained correctly. Flipping the magnetic field, the Earth will lose some gas. Some gas will bleed off into into space, which is not good. That's not a good thing. We don't need our atmosphere going anywhere. Even changing the atmospheric composition of this planet just a little bit will really, really screw up the climate. Like, for instance, if the magnetic poles, if Earth got hit with a big enough solar flare and it flipped the poles, right? And we lost 20% of the atmosphere. That 20% could be the 20% with oxygen in it, because there's 20% oxygen that you're breathing right now. And if the atmosphere bleeds off all the oxygen for whatever reason, and there's only nitrogen left, well, I hope everybody has a spacesuit. But see, like, here's the thing, guys. Don't get me wrong. Earth is pretty robust. It's been around for millions of years. Billions, actually. Millions in its current kind of, as we know it, in its current state as we know it. I wouldn't be too worried about it. With that being said, like, you know, CMEs, you really can't do anything about it, so who cares? Why bother? Okay, great, it's gonna mess up some electronics. You can buy more electronics, that's fine. Hey, Hootser, 6-month resub. Thanks, buddy. It's not the first time that it's happened, and it won't be the last, guys. It's just information travels fast, so, you know, it's humans playing the telephone game. Remember that game, Telephone, where you pass a message around, and then when it gets back to you, it's completely different than what you said. Long story short, CMEs do happen. It happens. You've probably never heard about them happening before. They happen all the time. Hearing about, you know, interstellar weather is as weird to the average person as hearing about the weather from another city. You know, you don't flip on the Weather Channel in New York City and get Los Angeles' forecast, right? Like, I mean, do you know what the weather is like in Los Angeles, if you don't live there offhand right now without Googling anything, no. Hell no. No way. So, yeah, it's just space weather and that happens, man. It's basically a thunderstorm. Could damage some things, probably won't. Franco, 43-month resub. Thanks, man. Pretty much, Synerd, yeah. Sunny and on fire. Actually, it was raining in California very recently, guys, so. Dumpeel, I wouldn't worry. I wouldn't worry. The worst thing that stuff's going to do is flip some bits, in which case you restart your computer and it works just fine. Some software might not work correctly. That's about it. But here's the thing. A lot of critical infrastructure around the world is rad shielded. There's a good reason for that. Well, first and foremost, a lot of the stuff is rad shielded because, you know, there was this thing with us wanting to blow each other sky high with nukes for a long time, but also because of stuff like this. Most infrastructure is not rad shielded, but the critical stuff absolutely is. During the break video, could you show KSP2? It's like 15 minutes. I wanted to do that when we go to start playing Kerbal, Gaw. But, yeah. Here. I'm going to go on break. I'll be back in a little bit. Brimo bought Chinese food, so I'm going to go have some Chinese food. I'll be back in a little bit, dudes. Here, I'll tell you what. I'll put on something. Here, give me 1 second.
Sunday, April 12, 1981. Kennedy Space Center, Florida. The Space Shuttle. 14 stories high, 2,000 tons, poised on the pad for its maiden flight. This is Columbia, the spaceship that will orbit the Earth. Its external tank. It holds over 500,000 gallons of fuel for Columbia's 3 main engines. And the solid rocket boosters, the largest ever used on any launch vehicle and the first to be employed in a U.S. manned flight. At liftoff, the solid rocket boosters, together with the 3 main engines, will unleash more than 6.5 million pounds of thrust needed to launch the world's first reusable spacecraft. Never before has a winged vehicle been launched like a rocket, orbited the Earth, returned through frictional heating in excess of 2,500 degrees, and landed, still aerodynamically sound, to be launched again and again. If it succeeds, the space shuttle will truly be a remarkable flying machine. There are many other goals to be reached during the 54.5-hour mission that lies ahead. 144 test objectives are planned for the flight. These objectives could not be achieved without an astronaut crew. The commander, John Young. The pilot, Robert Crippen. Young has already been in space 4 times for a total of 533 hours. He is the most experienced astronaut flying today. Although Crippen has over 4,000 hours of jet aircraft flying time, This will be his first time in space. The astronauts make their way across the access arm toward the shuttle in the pre-dawn hours before launch. An American spaceship has never carried a human crew on its maiden voyage. At the Launch Control Center, 3 miles from the pad, final steps are being completed in the countdown. Final preparations are also being made in the Mission Control Center in Houston, where control of the flight will switch once the shuttle clears the tower. There has not been a manned launch from Kennedy Space Center since the Apollo-Soyuz test project in July of 1975. With this launch, Young and Crippen, launch controllers at the Cape, and flight controllers in Houston will experience the most dynamic, fast-paced series of launch events ever undertaken in the space program, all in less than 9 minutes. The most challenging ascent profile ever to be flown by a space vehicle. Photographers, film and television crews, plus newspaper and magazine writers from around the world, nearly 2,700 of them are here to cover the launch. In addition, approximately 600,000 spectators line the coastal area near the Kennedy Space Center. Arriving by every mode of transportation, they have come from every state in the Union and many foreign countries. The promise of a rebirth in America's manned space program and the dawn of a new era in space transportation awaits.
14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start.
Roger, roll.
The roll will put the shuttle on its precise heading toward an imaginary target in space.
Roll program complete.
Roger, roll complete.
Discovery, go at throttle up. They get a status. Vital, go. Booster, go. GNC, go. Eagle, go. Go at 40, Capcom.
Columbia, Houston, you're go at 40.
The shuttle is now 40 seconds into flight.
Roger, Columbia, on the nice ride. You're lofting a little bit. You'll probably be slightly high at staging.
Negative seats.
Columbia, you're negative seats.
Should anything go wrong, the shuttle is now too high for the astronauts to use their ejection seats.
Columbia, you're go for SRB step.
We see SRB step flight.
Roger, on a step.
103 converge flight.
Bet.
Capcom, let's tell them all the calls are going to be a tad early because of the hot first stage.
Columbia, you're looking a little hot. All your calls will be a little early.
Okay. Map looks good here.
Stand by, press to MECO.
Columbia, stand by. Press to MECO.
Mark it.
Mark. Press for MECO.
Roger, press for MECO.
The shuttle can now continue toward MECO, main engine cutoff.
They like the VAP, Eagle. ECOM. Let's go, flight. Capcom, Vaps, go. Stand by, negative return.
Columbia, stand by for negative return.
Mark it.
Marked. Negative return. And your revamp is good.
Outstanding. Sure is. We can confirm it. What a view. What a view.
And single engine rotor flight.
And Columbia, your single engine rota.
Columbia can land safely at the Naval Air Station in Rota, Spain, even if 2 of the 3 main engines should fail. Right now, the engines are generating over 42 million horsepower.
Miko 25, 6,
Miko.
0 up at 220.
Roger, Miko. And we got Miko confirmed. Miko
Roger,
confirmed,
Columbia,
and it's
Miko.
right on the money, nominal.
Main engine cutoff. Columbia is now in space, traveling over 18,000 miles per hour.
Okay, we got set.
Roger, we confirm the SEP, Columbia.
The external tank has just been jettisoned and is now falling away from the shuttle back toward Earth. The tank will break up as planned over the Indian Ocean when it comes into contact with the atmosphere. Shortly, by firing the OMS, Orbital Maneuvering System engines, Columbia will achieve orbit. Then one of the most important tests of the mission will be attempted, opening the payload bay doors. The doors must be opened before the end of the 6th orbit to expose the space radiator cooling system. If the radiators cannot be exposed, heat collected from the onboard electronics cannot be released, and the astronauts will have to return home. The OMS burns are successful. Columbia is now in orbit, circling the Earth at an altitude of approximately 150 miles. The payload bay doors will now be opened.
Okay, the port door's coming open now.
Roger, copy.
Well, you are missing one fantastic sight. Boy, that is really beautiful out there.
We appreciate those updates.
Both doors have been opened. The radiators can be deployed to begin dissipating the heat.
The doors are all opened up and hunky-dory. Glad to deploy it right on time.
And the radiators look good.
Okay, we want to show you our own pods here. We do have a few tile missing off of both of them. Off of the starboard pod, 3 tile and some smaller pieces, and off the port pod, looks like I see one full square and looks like a few little triangular shapes that are missing, and we're trying to put that on TV right now.
Roger, Crip, we can see that good.
From what we can see of both wings, tops and leading edges, though, all those are fully intact.
Within minutes, an assessment is completed on the impact these missing tiles could have on the remainder of the mission. At a news conference later in the day, Flight Director Neil Hutchison answers questions from reporters.
Well, you asked me if I knew where there were any other tiles that might be loose. The answer is no. And quite frankly, we're not worried about any other tiles being loose.
At this writing, is there anything at all that would lead you to say you might not go for a full duration mission?
Nothing.
Columbia, Houston, you guys did so good, we're going to let you stay up there for a couple of days. Your gopher on orbit.
Spacecraft let's go for on orbit. This thing is just performing just outstanding.
Roger, we agree with that. And Columbia, Houston, just for your information, you dropped those SRBs right on target, and they were floating just the way they ought to be, and the boats were getting ready to fish them and bring them back.
Okay. The ride that they gave us was pretty neat.
The solid rocket boosters, which separated from the Columbia as planned 2 minutes 11 seconds into the flight, landed on target in the Atlantic Ocean, 151 miles downrange from the launch site. After being towed back to Kennedy Space Center, both boosters will be refurbished and used again in a future shuttle flight. The third and fourth OMS burns are also successful, raising Columbia's orbit to an altitude of approximately 172 miles. For the first television transmission from inside the spacecraft, the crew will give a status report on the mission.
The flight so far has gone as smooth as it could possibly go. We've done every test that we're supposed to do, and we're up on the timeline, and the vehicle has just been performing beautifully, much better than anyone ever expected to do on a first flight, and no systems are out of shape. And it's delightful up here in zero gravity, might add. Of course, we owe this to a lot of people, and we certainly want to thank everyone who has helped get this thing airborne, and can take great pride in it's doing so well right now. Okay, we're switching over to the aft camera here. I'd like to echo John's words as I usually do. I guess being the so-called rookie on this flight, I had a thrill from the moment of liftoff all the way up to what we're doing now. It's really been super. The spacecraft has worked as advertised all the way along. I think we've got something that's really going to mean something to the country and the world. This vehicle is performing like a champ, like all of us that have worked so long on it knew that you would.
Okay, sure, we appreciate those comments.
I guess that does it.
That was a good time, and I think you must have practiced. We're just about to lose your gold song.
Just accident.
Just accident, says Robert Crippen. None of the other events of the day have been accidental. Every test, liftoff, SRB separation and recovery, ET separation and impact, 4 OMS burns, payload bay door latch opening and closing tests, radiator latch deploy and stowing tests have all been successful.
I guess we owe you guys one super attaboy for today. This is fantastic. You worked through a pretty long, hard day, and you're essentially right on schedule, which is going to be close to being a first sort of spaceflight biz, I think, for first day activities. It's sure been fun working with you today, and we look forward to seeing you in the morning. I hope you get a good night's rest.
Okay, you guys did super work today. See you mañana.
Roger, thank you. See you tomorrow, guys.
Well, many hours went into this thing. A job well done by the shuttle space team. We can't say that she's sleek and lean, but I'll tell you right now, she's a mean machine. The Columbia, not the kind you smoke. This here's a bird.
Morning, Columbia. Welcome to day 2.
All right. Appreciate that super wake-up music this morning. Well, we sure enjoyed it. Missing a good breakfast.
Today, the astronauts will test onboard systems and also review procedures for tomorrow's landing. A test of the flight control system is conducted by John Young. The flight control system operates Columbia's aero surfaces, the elevons, body flaps, rudder, and speed brake. These surfaces are useless in the vacuum of space, but will be essential tomorrow when the shuttle lands. This will require precision maneuverability, which the aero surfaces provide. Payload bay door cycling tests help ensure that latching and closing procedures can also be done before entry tomorrow. As with every mission, many pictures of the Earth are taken by the astronauts. Over 500 on this first shuttle flight. Active volcanoes, cloud formations, alluvial fans, giant whirlpools over 15 miles in diameter, sand dunes 1,500 feet high, running unbroken for hundreds of miles. The high Himalayas, where mountain peaks reach 24,000 feet. And one of the most remarkable space photographs ever taken of the Earth, an area in Iran exposed to wind erosion, which has resulted in these breathtaking silt and sandstone formations that look more like a painting than a desert. After lunch on the second day, the astronauts receive a phone call from the Vice President of the United States, George Bush.
How's it going up there? Everything rocking along all right?
Spaceship is just performing beautifully.
Well, it's great, and everybody views it, I'm sure, just as the forerunner of great things to come. I think your trip is just going to ignite the excitement and the forward thinking from this country, so I really just wanted to call up and wish you the very best.
We certainly appreciate it, Mr. Vice President.
The crew also don and check out the ejection suits they will wear during entry. Young, Crippen, and Columbia pass every test. They are ready for the final phase of the mission, entry and landing. April 14th, 1981. NASA's Dryden Flight Research Center on the edge of Rogers Dry Lake Bed in California. A recovery convoy of 24 vehicles and more than 100 personnel are assembling here to power down Columbia after landing. Enormous crowds are also beginning to arrive. A string of traffic 6 miles long waits to enter the base. Thousands more are already here. Close to 500,000 people will eventually be on hand to see the landing. On board, the astronauts suit up for entry. The ascent and orbital phases of the mission have gone extremely well. Now the final phase must be completed. Before that begins,
Columbia, you have a go for payload bay door closing.
the doors, which have been open a total of 47 hours during the flight, must now be closed. Then, using the RCS thrusters, Columbia will maneuver into deorbit burn attitude, head down and backwards, fire the OMS engines one last time, and descend into the Earth's atmosphere.
Nice and easy does it, John. We're all riding with you.
Columbia is out of contact during the OMS burn. Mission Control will not know if this burn was successful until they are in communication with the spacecraft over Australia. It is now over the Indian Ocean on the other side of the world, but from that distance the burn must be precise so that later Columbia will hit the lake bed target in California.
Columbia, this is Houston through Yargady. We're standing by.
Burn was on time at nominal reserve 110.
Columbia is now committed to entry. With an RCS post-burn maneuver and several firings, it is oriented to a heads-up, nose-first attitude headed toward entry interface. This is where the atmosphere begins, at approximately 400,000 feet. From that moment until the shuttle reaches 165,000 feet, it will be in communication blackout, out of touch with Mission Control for almost 20 minutes. The landing site is almost 4,400 miles from entry interface. Chase planes are preparing to take off. One will call out altitudes and check Columbia for any damage just prior to landing. When the shuttle touches down here, it will be traveling at 216 miles per hour.
Yeah, Jazos.
Right now, it's going more than 17,000 miles
Shuttle
per
stays.
hour.
It flies
Before
on a very.
it lands, it must slow down.
It flies in a or flew on a very shallow re-entry trajectory, hence the long blackout period. The capsules nowadays can right through. It's like 10 to 15 minutes, but the shuttle was 20 because it stays up there. It stays way up there because it needs to slow down. The shuttle's thermal protection system can't take dipping into the atmosphere too much too fast. It'll become unstable. So it has to kind of just float up there, and then basically once it's slowing down enough, it'll just take a nosedive into the atmosphere. Starship will do something very similar. There's your S-turns.
208,000 feet. During these two roll reversals, entry heating is most
Reversal, let's turn
severe,
right.
with temperatures reaching
I'm good, Forge, I'm
2,500
good.
degrees
Watch.
some places on
He'll
the
flip
vehicle.
it back over to the other side.
The aluminum skin will melt
Ugh.
at 320 degrees.
Wait
The
for it.
silicate tiles must insulate the vehicle from the tremendous heat.
Come on, flip it back.
Since there is no test facility on Earth to simulate the aerodynamic and structural
Hey,
environment
what's up?
Columbia is in right now, only calculations could be used to predict what would happen during this phase of the flight.
Oh man, he's really turning that thing to the left. Oh, that's awesome. Oh, that must have been so fun.
The
I would
predictions
enjoy
and
that.
calculations
I would enjoy that all
had to
day.
be right.
Hello there, Houston. Columbia's here.
Hello, Columbia. Houston's here. How do you read?
Flying clear, and we're doing Mach 10.3 at 180 AS.
And we couldn't agree more, John. Your state vector's good. We've got good data in-house.
Okay.
The entry trajectory, velocity, and position look good. Columbia is heading for home.
Pretty much, Shaw.
Now only 470 miles away.
More left RCS, but okay.
Right, we're showing a roll.
Roll reversal
And
right.
John, we're showing you rolling right. Looking good.
That was that. They just showed the picture of that. The shuttle flipping like this.
Columbia, we show you crossing the coast now.
What a way to come to California.
The shuttle is first sighted at about 100,000 feet with a long-range camera from
33
Anderson
kilometers.
Peak, California.
What a way to come to California.
In flight pattern, I still look perfect right on the nominal.
No, they
Roger
clustered
that.
thrusters,
Out of
Steiner.
112K, 4.8
Not big
knots.
thrusters. They had clusters of them. Woo! Oh, look, there's Bakersfield.
We see Dallas 21.
I never noticed that before.
A roll reversal is done over Bakersfield, California.
Well, there you go. I knew it was Bakersfield because the road, the diagonal road going through the farms. I know what Bakersfield looks like on a map. It's not that I've just seen this video 1,000 times, I swear.
Oh, that's beautiful.
I haven't watched it yet, Sonic.
Trace has a tally. Roger, checking.
And we're seeing 1.3 Gs coming around the hack.
Roger that.
Final turn for heading alignment. There's Edwards.
The astronauts are making the final turn to line up with the runway.
Columbia, you're really looking good. Right on the money. Right on the money. And turning on to final, your winds on the surface are calm.
Back on the wind.
You're right on the glide slope, Columbia.
Clear, John.
The Fields doesn't. Well, the highway hasn't supercraft.
Looks real good on the news. Everything looks real good.
Chase reports no tile or other damage is evident underneath the shuttle. Columbia's
dude, what's
altitude is
going on?
now just over 5,000 feet.
Come on, baby. I know what happens. It still gets me fired up. I'm sorry, it still gets me fired up, dudes. Look at the nose down. Unbelievable. Whoa!
Columbia must land.
That's ballsy,
It cannot
dude.
make another
Jesus
attempt.
Christ. Oh, man.
You're coming.
That's awesome, Jack.
You're down.
I love this shot. It's my favorite. Look at how crisp that is. Oh, she's pretty. You had to do it at the last second or else you'll stall, Wes.
40, 30, 20, 10, 5, 4, 3, 2, 1. Touchdown.
Greased. Greased.
Gear, 10,
I would expect nothing less from John Young.
5, 4, 3. Touchdown. Look at off, skipper.
Houston, Columbia is on the rollout.
Houston, Columbia's on the rollout.
Welcome home, Columbia. Beautiful, beautiful.
You know it's copied from the Russian Buren. No, it's not. It's absolutely not.
You'll have to take it up to hangar.
You're getting confused. You got that reversed.
We're going to dust it off first.
is the world's greatest all-electric flying machine, I'll tell you that. It was super.
Convoy's on its way.
Okay, convoy's on its way.
Convoy on. We'll stop on the Columbia. We'll stop.
Venus is Russian, though. Yeah, that's right.
The maiden
Look at the
voyage
dudes walking
of
around. Look
Columbia
at how big
has
that
been a
thing is.
success.
It still gets me every
The
time. I've
astronauts
seen these
and
things
the
in real life.
vehicle have
I've watched
met
one
or
launch.
exceeded all
Still blows my mind how
144
big the
flight
thing
test
actually is. It's
objectives.
freaking huge.
The integrity of all
No,
the
Taco,
systems.
he couldn't make it.
Propulsion, avionics, structural,
This is the best part.
flight control,
Look at,
power, and
look at
thermal.
John Young starts
have been
nerding out.
affirmed.
It's my this is my favorite.
John Young's comments after returning home.
I can't tell you what a tribute that is to the American working man and the American working woman, too. You can't imagine the variety of people who worked on this vehicle, from all walks of life, all capabilities and limitations. It's all due to their individual efforts. They proved that they can do the job. They proved it for the world to see. And I'm mighty proud to be associated with folks like that.
What a tribute indeed. The Columbia represents an achievement in aerospace technology and development never before realized in the history of manned spaceflight. It is our basic building block for the future.
It's what we've been trying to do for the last 10
John is the
years.
goat.
We've got
Oh,
a
man,
vehicle
did you see
with a
this
payload
thing?
performance that
Yeah,
will allow
wow.
us to do that, much
It's my
cheaper than
favorite-
we've been able to
It's
do
my
before.
favorite part, dude.
It will immeasurably improve the defensive capability of the country. It will help develop space science and technology. When we get operational, the space shuttle will be able to do in 5 to 10 years what it would have taken us 20 to 30 years to do otherwise. We couldn't do it if we didn't have the space shuttle and that payload capability.
Can you link me this video? Yeah, sure. It's a good video. Okay, this is my favorite part. Here, I'll show you. Watch. Here, I'll shut the sound off. Just watch this. Watch. Oh man, did you see that? Here, this is what John Young's thinking. Oh man, did you see that? Here, let me put this down. Man, did you see that thing flying? You see me fly that thing in here, man? I freaking took that thing down, put it right down on the runway. Oh man, that was awesome. Oh man, I want to shake your hand, man. Oh, thank you for doing this. Did you see that? You see this thing come in? Hey, thank you for what you're doing. This thing, I tell you, just, this thing, yeah. This thing's the best. Wow, who else's hand can I shake? You see that over there? No, man, I didn't see that. I'm gonna go look around this thing. John, you need to go into the truck. No, I'm busy right now. Oh, wow. This is great. Oh, you did a good job, man. Wow. This is fantastic. You got it, dude. Think his adrenaline's going? He's just, Oh, man, I'm going to flip my pen now. Whoop! Oh, that's cool, man. It makes me happy seeing John Young. He's like, man, you see me bring this thing in, man? Back in 1982, I brought that shuttle right down. Landed it right on the runway. That's my favorite. Makes me so happy.
Go and throttle up.
See how freaking into it he is. Oh man, that gets me hype. Yeah, exactly, Monkey. He's like, man, did you see this thing? You see this thing freaking come in, man? Holy crap, this thing's amazing. So good. Yeah, shot with a plane next to it, flying chase. Overdrive, what's up, man? 34-month resub. Man was passionate about what he's doing. That's right. Is there any recent interview talking about his first flight? I'm sure there's something around Supercraft. Yeah. In 2011 was the 30th anniversary of STS-1. I'm sure him and Crip had something to say. Then he went and did it again. Yeah. That guy, man. John Young was my freaking hero. Yeah, he might be gone, but holy crap, man. I strive to be like that dude. I want chocolate ice cream. All right. Why are you telling me? Yep. First and last cruise right there, Bandit. Did you see this? It's coming in the space news. This is how I wanted to start up space news for the day. Man, just look at how freaking big the damn thing is. That still gets me, man. You know, it's very rare that you see a shot like zoomed out like, well, not very rare. You just, you know, if you Google pictures of the space shuttle, you're not going to get a picture like this. You're going to get a picture of it up close. See people walking around next to the thing. I mean, really drives home just how large the freaking thing is. Like, guys, I've studied this thing. I know all about it. I've seen every surviving orbiter. Well, and even the ones that haven't. You know, like, I've seen external tanks up close, SRBs up close, shuttles. You don't get the scale. You don't get to see the scale of this thing. It's freaking huge. Because I thought it might help. Maybe I should just get it delivered. All right. Part of me wishes there was a safe way to display a real space shuttle outside. They look insane parked outside. Yeah. Yeah. If they ever do what they're trying to do at Endeavor, maybe. Ride cooking? That's crazy, man. Crypt comes out. He's like, hey, you left me in there. Yeah, sorry about that. Look at how hyped these guys are. The thing is so freaking cool, man. It's not every day. Okay, for the people that don't know who John Young is, that guy was like the Kimi Räikkönen of astronauts, all right? He just stone cold, Iceman, the entire time. For him to be smiling, like he walked on the moon. He was just like, yeah, that's cool. All right, that's neat. Seriously, John Young was Kimmy. He was the Kimmy of frickin' astronauts. It doesn't just... Yeah, that's nice. That was pretty neat. Yeah, he was told about the approval of the shuttle. Yeah, he was walking on the moon when NASA switched to the shuttle program. And they were like, hey, we're getting a shuttle. And he's like, oh, that's neat. I'm on the moon, though. But yeah, that's cool, too. How many tiles did the shuttle lose on the first flight? A couple here and there. I mean, Exil, I've read stuff about, you know, like heart rates and stuff on STS-1. Like, in the final, 15 seconds, Bob Crippen's heart rate was like 120, 130 BPM. John, 80. 80. This is neat. Yeah, I'm about to launch on this. No one's ever launched on it before, but that's okay. That's fine. Do you want ice cream? No, Remo, I'm all set. Chinese food was more than enough. You fed me today. Apparently there's a Buran replica in Sochi. At least there was when there was F1 this year. Cool. Ice in his veins, dude. Or even ice cream in his veins. Lieutenant Dan, ice cream. All right. So, here, check this out. Let's start the space news. You guys like showing the intro videos like that while I'm eating? I think that's a cool idea. I think I'm pretty much gonna do that from now on. We'll do movie night in the break spot. Quote unquote. Back when test pilots had to have stones. Yeah. They still do to an extent, but yeah, we don't test stuff as much. Most of it went on the computer. Most of it happens on the computer, but... Okay, so there's that. We have that video. There's that. Let me load up the Starship stuff here. We had the chopstick swing from Mechazilla for the first time. That's cool. Starship test pilots when? You know, I've often wondered about that floating. You put a kappa after it, but when you think about it, like, Eventually, they're going to have to put a flight deck on Starship if they want people to fly it. Surely you won't fly with automated... You won't fly it automated the entire flight with no opportunity to intervene from somebody on the craft, right? It's going to need a flight deck at some point. The BA is Joe Engle flying the shuttle. Joe Engle is the only guy to ever fly the shuttle manually from orbit to the runway. Him and Richard Truly did it on STS-2 just to see if it could be done. They literally shut off the SAS and flew the thing manually through space, which is unreal. Why a flight deck? Ballast only. It moves 100 tons into space, Soapbox. What are you talking about? Starship with a small deployable cockpit in case of an abort. I don't think we need that either, Ka. It's probably going to need something like the space shuttle's flight deck, right? You got to have a place where you can, on board, where you can diagnose the vehicle. It's probably going to be something sleek like Dragon 2, right? Like, if you just took Dragon 2's interior and just put it in the nose cone of Starship and called it a day, like, it's got to be something like that, right? Like, you don't necessarily need like windows. It's not like the space shuttle. Dragon does the windows on Dragon don't. I mean, you don't. The pilot and the commander aren't. They're looking at screens that's looking outside. They're not looking out a window. The control center, yes, but a flight deck, I don't know. Yeah, exactly, Vulcan. He ended up being a NASA administrator too, if I'm remembering right. Yeah, but when you think about it, you can't really pilot this thing with a human. Yeah, that's a good point. Do you think you could fly-by-wire land one of those things? Like with a computer interpolated inputs from a person? Do you think someone could manually do it? I mean, we did it in KSB, Shaw. I'm not sure about being able to do it accurately, but we did it. Picard could. Nice. About the most you could do is tell it to start the landing maneuver. Yeah. If it works in KSP, yeah, I know, it's a joke, right? I'd love to say yes, but not a chance. Yeah, I don't... That's like asking a plane to... Well, then again, I was going to say, that's like asking a plane to touch its tires down in the exact same spot within like a meter deviation. But then again, Starship's landing doesn't... If they're going to land it on pavement and not catch the thing, maybe. I don't think a person could do the flip in the landing. We've done propulsive landings on other celestial bodies, guys. Like, I don't know. All I know is that I couldn't. On the moon, it's possible. Well, on the moon, you're not gonna have to do a flip. Yeah, Lunprod, cool. I seriously doubt humans would have the precision to steer the tower, to the tower. They'd need some type of instrument landing system, Mile. You'd need an ILS for Starship. It would have to. You'd have to have something like that. Mainly controlling offset thrust would be interesting. Yeah. How many G's during the flip? Not many, Snickers, considering the part where the people are is not rotating very much. Like, if you consider how Starship pivots, what's the part that's doing that's moving a lot during the flip? It's the engine section. So it'll basically feel like doing this. Like, it'll feel like it should feel about the same as a plane nosing up. Like during takeoff, it should be about the same, only with a little bit more rotation than just, this to that, Bit off topic, have you played Re-Entry before? No, I never have. With enough practice in an accurate simulator, I have no doubt a pilot and co-pilot could do it. Sammy, I think it's possible. I think it's possible. You'd need assists. So, like, guys, think about how, like, an F-16. So, the F-16, the joystick on an F-16 is not It's not like it's pulling on some wires that are pulling on the control surfaces. No, the joystick, the information that gets inputted on the joystick gets interpolated by a computer and then applied to the flight control surfaces through electrohydraulics. It's basically going through a flight computer, right? Doing that should, with enough assists, yeah, you should be able to. I don't see why you wouldn't. It's not impossible. I think it's just a little far-fetched for us right now. It's as far-fetched to us right now as an instrument landing system would be to a pilot in the 50s. In the 50s, it's just, okay, there's the stars. We're going to fly in this direction for this amount of time, and, oh, we look out. Yep, okay, there's where we're trying to go, you know? Like, there was no GPS. You had to use maps, and, man, if you were off by, like, a degree, that's it. That's game over. You're going to miss your target by thousands of miles. It happened all the time, right? And then they started using radio beacons for planes to home in on a target. And then they started using frequencies, certain frequencies with radio waves to have the plane home in on the runway. So, fourth wall broken. No, it's not a wall. It's a cloth because it's a green screen. It'd be more like landing an F-35. The computer would do the heavy lifting. Yeah. I think it's doable. Guys, I think it's doable if Starship was landing on a concrete surface or like a landing pad. I'm not sure it's doable if if Mechazilla is gonna try to catch the dang thing. Fourth cloth broken. Yeah, okay, there you go. There. The question is, at what kind of situation would this be better than letting a computer do it on its own? Yeah, Laz, that's a good point. I mean, yeah, that's a good point, Lazarus, right? You're right. So, let's take Dragon 2, for instance. Dragon 2's descent is pretty much all automated. Even the shuttle was, for the most part. When the shuttle's going through the fiery stuff, they only flew it manually once just to see if it would work. That was on STS-2. We talked about that. Even the shuttle going through its roll reversals and stuff, that was all automatic. They did that using ground stations to be able to see where the shuttle was going. And then, you know, once you got through the fiery stuff, that's when you'd flip and you'd take manual control to land the shuttle, right? It's probably because they just didn't have the mass for any type of automatic landing system. But then again, who knows? Maybe the tech just wasn't there. They did start designing the thing in 1972, so who knows? The first scheduled U.S. airliner using ILS was in 1938. Oh, okay, W. Thank you for the clarification. You get what I'm trying to say, though. Regardless of the dates in the analogy are just to provoke a picture, I suppose, or some type of relativity here. Buran could land by itself. Yes, it could. But Buran is also a lot lighter. It's a lot lighter than the space shuttle because it doesn't have its engines on it. Now, don't get me wrong. I don't think that's going to make that big of a difference, but it might. Who knows? And once again, I'm not hating on Buran either. Like, Buran's it's a fantastic spacecraft. Energia is where it's at. Glushko. That's where it's at, dude. Buran is okay. But Energia is the one, that's the lifter that makes a difference. You could put whatever you want on the side of that thing. Put whatever you want on it. You want to put a tank on the side? Sure, it'll launch that into space, no problem. You could, and I mean literally, you could literally bolt like a T-72 to the side of Energia and it could put it in space. Think about that for a second. No fairing. And I know what you're going to say. Oh, EJ, what do you mean? Tanks aren't accurate. You need to put it inside a fairing. Is a tank as aerodynamic as Buran is? I'm pretty sure one of those things makes more drag than the tank. One of those things makes more drag than the other. The orbiters generate way more drag than a tank ever could. Seriously. There's a big difference between plane auto flying and rocket auto landing. Well, Monica, that's why I said it's more like Dragon 2 then. How, like, in what scenario would you be able to take manual control of chute deployment? I'd probably have it there just as like a redundancy, just in case. You never know. Maybe something goes wrong during the flip maneuver, right? And they have to divert to another landing pad or something. Like, maybe there's something with the computer or whatever. Like, I would still have that back door in there just in case. But once again, I'm thinking that SpaceX will probably end up having it fly more like a pod than anything with automated, right? But man, wouldn't it be cool to see someone manually plop a Starship down? That would be pretty neat. Could Energia launch the nuke satellite 50 tons from Space Cowboys? Sure. Yeah, why not? I like the Energia Vulcan idea better. 8 Zenit boosters. Yeah. Feeling better? I'll be all right, Spiffy. I'm putting on my brave face today and hoping it doesn't end well. IMO, we'd have to have people propulsively land a Dragon capsule first. What? Why? Energia Vulcan? I wonder if that's where I got my name from. Nice, nice. I think it's like Elon said one time about not having an escape system. They just want Starship to be so reliable that they don't need one. I agree with you, Lazarus. I would still have that redundant capability. Heck, Dragon does. Dragon has manual deploy on things and manual re-entry. They're the buttons below the screens for like if the poop absolutely hits the fan, you can manually trigger events. I mean, heck, Starliner has all redundant mechanical controls on top of its electronics. So did the shuttle, for what it's worth. That's why the shuttle has so many buttons. Shuttle didn't need all those buttons on the walls. Like, if you look at a shuttle orbiter, right? There's buttons everywhere. But all these buttons are manual to the computer. They're the manual redundant backups. See? That's what all this extra stuff is. You can fly the thing with the MFDs, with the computers. And then there's your IMS. That's where you inputted different parts of the ascent trajectory, but you still have manual redundant controls here, 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 here. Manual fuel gauges on top of digital fuel gauges. That's what this is. These are your RCS. That's your RCS fuel and orbiter maneuvering fuel. RCS OMS. If we could get a clearer picture, I could tell you what each one does, but I want to see a Starship cockpit. And that's what I'm saying, Ka. Like, what would a Starship cockpit look like? You know, like, what would that look like? They're eventually going to have one. Oh. Man, did that design change. Like, see, SpaceX has manual redundant buttons down here with button shields and stuff. Are those CRTs in the shuttle? They started as CRTs, Deathly, and then in the 2000s they started not fixing it. They started giving them glass cockpits. That's actually what the last Columbia's, that's what it was basically going to do. Columbia, after STS-107 was going to land, and they were literally going to gut it. They were going to take the whole thing apart, like entire shuttle apart, and put it back together with modern components so it could support ISS operations. A lot of folks don't know that the Columbia was way overbuilt. It was way overbuilt. That thing, it was built like a damn tank because they weren't sure. They had to overbuild it. It's not like you could test it because, once again, you need people to fly the thing, right? This thing was super, super overbuilt. It was really heavy compared to the rest of the fleet because it was the first one. They used what they learned about tolerances from this thing to make lighter orbiters. That's why I like Challenger. Challenger is my favorite because it took all the knowledge from Columbia, all the stuff that they learned from the first 4 test flights, and made a much lighter orbiter. They made just crazy improvements. Starship interior layout fan concept. Yeah. Elon said they wouldn't fly a person in Starship after a few hundred flights with the other versions. Well, same idea with Dragon, Jazos. Yeah, they did the same thing. Does that mean Dragon doesn't have flight computers on it or like a display? No. I figure it's going to be the same. You're going to eventually have to put people on that thing. And I'm pretty dang sure, at least during test flights, those people are going to want to have a way to be able to control the spacecraft if needed. Maybe even as a temporary measure, right? Like, who knows? Maybe they launch a Starship, and inside of the payload bay is a Dragon capsule. That would be really stupid. I wouldn't do that, but it's possible. That'd be kind of funny. Can you imagine a Dragon slaved to a giant starship, right? Or a starship slaved to a Dragon, and they're controlling the entire thing from Dragon, and if something goes wrong, they just pop the payload bay doors and separate and just re-enter with the capsule? Wouldn't that be ridiculous? That would be a super complicated mission. That's to the point where, like, that's not even worth it. Can we bring back Zond and strap a Soyuz to the top of a Proton again? Yeah, right. Escape pod design. Привет, Vasya. Как дела? Хорошо. Как дела? Anyway, so let's flip around here. So check this out. More news on the SLS front here. I talked about this real quick yesterday, but yesterday's space news was a fragmented piece of crap that, frankly, I should just delete the VOD. That's a Super EJ mission. Yeah, Ben, right? So, check this out. Exploration Ground Systems delivered 2 umbilical arms for the EUS. They started testing EUS components at Kennedy Space Center. We talked about the EUS 2 streams ago. Basically what that is SLS's beefed up upper stage. Right now, the SLS rocket that's stacked inside of the VAB looks like this. All right, it has an ICPS, an interim cryogenic propulsion stage on top, right? This is just for the Artemis 1 mission. Artemis 2 will fly on one that looks like this as well. Artemis 3 or 4 will have the exploration upper stage, which is basically, it looks kind of like, that's a good one. That's a good enough picture right there. A lot of people weren't sure if the EUS was going to be a thing, right? Like, you know, the EUS exists on paper. It doesn't exist, you know, anywhere else. But the CDR was completed for it, and they're already testing umbilicals. They're testing its umbilicals right there. There's the fuel lines for it right there. It's at the LETF, which is the Launch Umbilical Testing Facility. Yeah, it's a nice picture. And then we did the math out on this thing, Vulcan. Were you here for that? Oh, these pictures, though, are... hello. The EUS is NASA's saving grace. Man, they should have just designed it like that to begin with. When we determined it had more delta V than the Earth departure stage. Dude, we did a complex breakdown here. So, Vulcan, I did like the math out. We did the math out with the publicly available numbers about wet mass, dry mass, specific impulse of those engines, etc., etc. The EUS with no payload on top. So literally that, right there. That right there has 10,000 meters a second delta V. 10,000 meters a second. And I had my boys at NASA kind of check my. I know people that work not on the EUS, but I know people that work on SLS. I had them check my math. The math is right, which is unbelievable. Also, I have more pictures. News this week. Vulcan discovers NASA's image archive. More news at 12. It has 10,000 meters a second by itself, hand. No, with an Orion capsule and the universal stage adapter. So this thing right here, with an Orion capsule and a universal stage adapter, it has, I don't know, 8,000, 8,000 meters a second delta V. Long story short, we know Orion and all this paraphernalia on top here is about 25 tons, right? The Orion capsule is 25 tons worth of capsule and service module. The reason why it's so heavy is because it's designed for long duration stays in space by itself. Long duration meaning a couple of weeks, right? That's a lot of time to be in that capsule, right? You don't want to design a capsule with a life support system that can support people for 100 days, because no one's going to spend 100 days in space inside of a glorified gym locker, right? So the idea was you make the capsule relatively short range, and then you make the capsule attached to other things that make it that have more range, more delta V. So the Orion's 25 tons. Let me put it to you like this. You could put 20 tons of lead in the universal stage adapter here, and the EUS would have enough to throw that at the moon. Here's the crazy part. If NASA was able to find a way to mitigate Hydrolock's cryogenic boil-off, which is what they're working on right now, if they found a way to do that, the EUS could circularize an Orion and a 20-ton lander, or whatever. Let's say Orion and a 20-ton block of lead in low lunar orbit. So like EUS burns out to the moon. Halfway, they do a flip. They get near the moon. They fire the stage again, and they circularize. The EUS has enough payload capacity to throw up to like 70 metric tons TLI. It is unbelievable. I didn't really know this. I thought the EUS could do 40, and I've always said that 45 is the magic number. But we did the math out based off of NASA's numbers that they've released on this thing. It has way more delta V than that. It's a way better upper stage than even the S4B. Saturn V's third stage. It's way better than that. Like, way better. It's better than Ares 5's upper stage. In fact, I would take Ares 5 with an EUS on top of it. Let me put it to you like that. The ACES, ULA's ACES is likely going to be implemented into the EUS Mark II, which is expected around Artemis 6 or 7. Was that, where'd you get that bit from, Vulcan, if you don't mind me asking? I know your sources are concrete. Where'd you get it from? It's those RL-10s. That's right, Pigzig. Orion service module can leave low lunar orbit? Sure. Yeah. The Orion itself could circularize and get to the gateway and then decircularize and go home. If you're using the EUS to circularize in low lunar orbit, Orion has enough delta V because you're not using any service propulsion systems. Orion has enough to get from LLO back to the moon. I'm pretty damn sure. In fact, you know what? I'll prove it. Here. Let's go open up the RSSRO Delta V map, right? For all the advanced Kerbal players out there. So, you need about a 3,200 meter a second intercept. Minus a little bit from that. In LLO, you need 680, 32. Ooh, maybe not. Hang on. I gotta find the right picture. There's an infographic floating around. Fun people I know who were yoinked off the Centaur 5 program by NASA. Oh. Maybe that's why ULA isn't messing with ACES anymore. There's an infographic here that should show you your delta V. Oh yeah, there's your comparison between your Apollo and Orion capsules, by the way. Orion is a little bit bigger. I'm trying to find it. I'm trying to find how much delta V. What's the delta V requirements for circularization? Circularization in a rectilinear halo orbit. If I can get the rectilinear halo orbit insertion delta V, then we should be able to calculate this just fine. So 680 and 3260 are pretty much how much you need to go from low lunar orbit. And what these numbers mean, guys, for the uninitiated, is how much you have to change your velocity. Spacecraft range is not measured in distance, it's measured in acceleration, believe it or not. And I know, like, what? The name of the game with spaceflight is speed. The faster you can go, the further you can go. Distance has nothing to do with it. It has nothing to do with it because you can change your transit time. If you have more delta V, you can go faster, and it takes less time to go a certain distance, right? So, how fast you can go is how far you can go, or in the case of some rockets, how quick you can go, right? So, these numbers that we're looking at here, 680, 3260, are meters a second. So, think about it like this. Orion has to be able to accelerate to at least 4,000 meters a second. Because we have 680 and 3260, that's just below 4,000 meters a second, right? It's like 39 something or other. 3980? No, 3880, something like that. Let's just round it to 4,000. It's an easy number. So if Orion has 4,000 meters a second delta V, basically that the engine on the back of an Orion capsule can accelerate from, in an ideal environment, right? Can accelerate from 0 meters a second to 4,000 meters a second, right? Then it has enough fuel to be able to get from low lunar orbit, so a close orbit around the moon, back to Earth. All you need to do is a transit burn, right? You need to do this 4,000 meters a second burn and then intercept into the atmosphere, and Orion's heat shield will absorb the rest of the deceleration, so to speak. That's not really the right way to say that, but it'll re-enter. It'll aerobrake. What the heck? It takes 27 kilometers to take off of Venus. Aerodynamics, big pain in the butt on Venus. A lot of gases to move out of the way. More than Earth, that's for sure. These were made for a real solar system, for Kerbal. But these numbers are right. See last two. Also, I was having more fun with the NASA image gallery and just audibly said "holy frick" out loud when I saw this photo. Yeah, that's a nice photo. What's the second one? ULA is working on ACES. It's just integrated into Centaur 5 enough that they aren't calling the whole stage ACES anymore. Got it. So, I forget where those insertion trajectories are. Yeah, Signer, yeah, something like that. Running a fan today? Yes, I am. So, I don't know what Orion's... Here, Orion capsule. Let's just try straight this. Orion capsule Delta V.
Discovery, go
Hey,
ahead.
Ronson. It's an 8-month resub. Service module mass. Service module thrust. Why would it just say the service module? Why not the crew module, dang it? Let's see. That's CEV though. That's not Orion. CEV is different. What kind of service module is flying on the first flight? What do you mean, what kind? I don't understand. Orion with the service module can use between 1346 and 1587 meters a second of delta V. Here's a solar system delta V map to get a sense of how much that is. Ooh. Ew. Yeah, no, it can't do that. Yeah, not even close. Gross. Okay, well, it could get an Orion to LLO, but it would need, the Orion would need an extra boost, a transfer stage or something to be able to get back. Gross. But what you could do is if SLS has with the EUS has up to 70 metric tons, 70, 80 metric tons TLI or something, or even 50 metric ton TLI, you just make an SSTO, a big reusable lander that you could go from the gateway down to the surface and back. If you launched it with no Orion capsule, that would probably be the better way to do that. Not space news, but it's fun to watch. What's that? Oh, I saw Jetson 1. Yeah. Either way, we got some flight hardware for this version of the rocket, the real version of the rocket, not the crappy one that we have right now. You mean like Starship? I mean, Starship could. Lunar Starship, yeah, Lunar Starship could do that. That's why, Cynerd, back in the day, we figured out that you can't do it. I think it's just too heavy. The ideal thing here, believe it or not, for the Artemis missions, and man, SpaceX people are not going to like this. The ideal way to do this is quite literally to put a Lunar Starship on top of SLS. Yep. There it is. Yep. Yep. It's way too heavy. SLS wouldn't be able to move it. It would crunch the SLS like an accordion. Yeah. Although, what you could do is launch an unfueled Lunar Starship on SLS. Unfueled Lunar Starship on SLS with just payload on board, right? SLS's core stage could basically put that pretty close to being on orbit. You use the Lunar Starship's thrusters, right, to circularize, and then you have a regular tanker Starship dock to it, refuel it, and then send that out to the moon. Aluminum hybrid SSTO for lunar operations. Hybrid SSTO. Why though? Well, Fractal, it doesn't really make sense unless you can launch Lunar Starship with a full tank of gas. If we could launch Lunar Starship with a full tank of gas, putting it on SLS would be a really good idea. Now, why? Why would that be a good idea? Well, if you did, and it wasn't too heavy, right? Carrying all that methane and stuff is heavy. SLS could put a fully, provided that the compression load wouldn't accordion the rocket, which it will. SLS has the Delta V and to be able to put a Lunar Starship with the EUS. So like core stage, SLS, EUS on top of that, Lunar Starship on top of that. It could put that into orbit. No problem. Yeah, it should be able to do it. I mean, Starship would probably have to use some of its fuel to circularize, but either way, worst case scenario, you have a Starship with at least a half tank of gas on orbit. Unfueled Starship can hold the G's? Sure, why not? Then why not just use Super Heavy? Because if you use Super Heavy, you have to refuel it. You understand that putting a Starship with a half tank of gas as opposed to no gas on board cuts your refueling flights in half, right? Like, that's the idea, Tomas. Because the thing about Starship is that Starship is very, very dependent on high frequency of flights. Don't get me wrong, that's SpaceX's stated goal, and I think they're going to do it. That's a lot of stuff to organize. A lot of stuff to organize. So instead of like having 15 flights to refuel Lunar Starship to get it to the lunar surface, now you only have like 5. See what I'm talking about? That's one launch to replace 15 launches. Or, well, not 15, let's say 7, right? That thing with the aluminum hybrid SSDO was using aluminum as the fuel with LOX oxidizer in a hybrid rocket. The benefit of lunar operations is that there's a lot of alumina in the lunar regolith. So the rocket's fuel is basically processed moon dirt. You're still going to need oxidizer, Steinert. You still need oxidizer for that. So you're still going to need to drill water on the moon to get your oxidizer. In a byproduct, I don't mean water, right? Let's H2O, right? You need the oxidizer to make O2, to make liquid oxygen, and that leaves you with H2, which you make into rocket fuel. Why would we do this? No. The oxygen is bonded to the aluminum and silicon. Caveman, SpaceX is already doing something like that. Depot starships, but I don't know what that entails exactly. SpaceX's outlined bid thing for like the Artemis program and stuff contains some type of gigantic starship refueling depot vessel that SpaceX doesn't really talk too much about. That basically is used to store fuel on orbit, so a starship can just jump up to it, tap into its fuel, and go. Yeah, I don't exactly know what that entails, but I would assume it's an orbital gas station. Yeah, they redacted everything about it, which is weird. I think those kind of engines only get like 250 to 275 specific impulse, though. I just don't understand why you'd want to do that extra stuff. It's not like you could put the lunar dust into a rocket engine and light it on fire and make a solid, right? Unless I'm thinking about this incorrect. You said hybrid engine. If the oxidizer is already chemically bonded to the alumina, right? Or aluminia or whatever, then you should just be able to pour a bunch of it into a rocket engine, light it on fire, and go. If that's the case, then yeah, I mean, maybe. But why do that when you can make hydrolox? Why do that when you can make hydrolox and have potable water for people to drink and have liquid oxygen? I don't understand. Why would we do that? I can link sources if you want, but a lot of the minerals are oxides on the moon. Aluminum oxides, iron oxides, so you don't need water ice for the LOX necessarily. If you're already doing ISRU to fabricate metal structures on the moon, theoretically you could shunt off some of that extract oxygen as a byproduct. Aluminum metal fuel, long time you get both of those parts from refining aluminum. Yeah, but you guys are overlooking you guys are overlooking the fact that you need a goddamn forge on the moon. And so you can go to the equators. What are the people gonna breathe? I mean, once again, guys, I'm not saying that this is impossible. Sure, that might be cool someday, but that's not something we're doing anytime soon. I'm not saying it's impossible. Yeah, you're going to need some type of smelting plant on the moon. Once again, also not impossible. But what are we talking about here? Are we talking about in the moon in 20 years? Are we talking about the moon in 100 years? Are we talking about the moon in 5? You know what I mean? The ISRU using hydrolox stuff is a moon in 5. Yeah, that's something that we can do. We can drill for ice. We have missions that are going to go to the moon, like Viper, that's going to do this stuff. And we have a mission on Mars that's already made oxygen, the MOXIE system on Perseverance. It's already done that. That's actually using the atmosphere, but that's another story. The point is that drilling for water ice and stuff like that is stuff that's technology that exists right now. Whatever you guys are talking about, yeah, I guess that's technology that exists right now too, but it doesn't exist in the context of the space program. You know what I mean? There's nobody researching that right now, I don't think. And once again, anything is possible within the confines of physics. Remember, people have proposed ideas of blowing up a nuke behind the spaceship and riding the wave of the nuclear blast to propel yourself in space, right? I think, personally, that's a waste of a nuke, if you ask me, but it's possible. Anything is possible within the confines of physics. I'm just thinking of ways to get almost anywhere on the moon from the lunar base. Okay. All you need to get a forge on the moon is to concentrate sunlight. You basically already have a vacuum forge if you have a crucible and a lens. You guys fucking get it. So why isn't NASA doing this then? Please enlighten us. Why isn't NASA doing this? If this is such a good idea, why aren't we doing it? Oh, there's that whole thing that people have to breathe. You know, that's important. Nobody here is saying this is a thing to do to hit 2024. But see, the context, Steinhardt, you say, no, nobody's going to say it if you're going to 2024. Remember, we're talking about this. Don't get confused. We're talking about the context of lunar operations in the next 10 years, at the very least. That's where this whole conversation came from. This whole conversation came from going to the moon in the next 10 years because we're talking about EUS and what the EUS can do. That was the whole, underlying, thing of this discussion. You guys getting confused? Or I'm like, I don't know. Yeah, sure, I guess that's possible. Yeah, and then, someday on the moon, cows can have spacesuits and we can make them fly around. Oh, I'm not saying that's possible within the next 10 years. It could be possible in the next 100 years. What? All right, great, good. Lovely. Next space news. Major Artemis engine parts arrived at Stennis for certification testing. Let's see. Ooh, look at that. That looks like an RS-25 power head right there. Let's see. The first 4 Artemis mission will use NASA's 16 upgraded RS-25 engines that previously powered space shuttle flights. For future flights on the Space Launch System, NASA and prime contractor Aerojet Rocketdyne are changing the way they build major parts for the RS-25. Engineers and technicians are fabricating some of these parts using advanced manufacturing techniques that increase reliability while reducing the cost and time to build the engine. The first RS-25 powerhead, produced by Aerojet Rocketdyne in over a decade, arrived at NASA's Stennis Space Center near St. Louis, Mississippi. Near Bay St. Louis, Mississippi. I'm like, wait, what? On October 25th. Here, it will be installed to a flight certification engine built specifically for testing newly designed parts of the latest production RS-25 engine that will power SLS flights beyond Artemis 4. With the Artemis 1 launch set to February, does NASA have a name for SLS? God, I hope so. It seems like we are in caveman times for space travel. More like the 1500s. The 1500s to sailboats, Goalie, is what modern nautical navigation is to, now. We basically have sailboats. Our spacecraft are basically sailboats. We got to come up with a better way to do it. Discount St. Louis, that's right. Let's see. Powerhead serves as the structural backbone in the RS-25. It houses 3 highly complex injectors that produce the combustion to power the engine and act as a jettison for several critical paths, including both high-pressure pumps and the main combustion chamber. Key powerhead components such as the main injector, heat exchanger, and structural forging come with cost-scheduled benefits due to the incorporation of advanced machining and forging processes, as well as a reduction in welds and part counts, making the powerhead more reliable. Powerhead Unit 7001 recently completed proof pressure testing at Aerojet Rocketdyne's site in Los Angeles, California. This test required the part to be pressurized beyond normal operating levels, confirming it is capable to safely operate the engine. Cool. The new powerhead, along with the other engine parts made from advanced manufacturing technology, such as the engine and main combustion chamber, will undergo hot fire testing on the same certification engine next year. The manufacturing changes incorporated into this new powerhead configuration are an integral part of NASA and Aerojet Rocketdyne's strategy to reduce RS-25 manufacturing costs by more than 30% compared to the shuttle predecessor. Nice. 16 new powerheads are currently in production as part of Aerojet Rocketdyne's commitment to deliver 24 new RS-25 engines. SLS and NASA's Orion spacecraft, along with the commercial human landing system and the Gateway in lunar orbit, are NASA's backbone for deep space exploration. SLS is the only rocket that can send Orion astronauts and supplies to the moon in a single mission. I added that little caveat to the end there, huh? I mean, it's a good point to make, but yeah. With Artemis, NASA will land the first woman and the first person of color on the moon and establish sustainable exploration in preparation for a mission to Mars. Interesting. Cool. Oh, yeah. The combustion chamber attaches right here. I think hydrogen is on this side. Oxygen is on that side. Look at that power head, man. That's really cool. There's your gimbal mount right there. This is the very tippity top of an RS-25. Man, look at that thing. What would the power head be in car talk? Intake port. Intake port. Hello?
Eat this.
Eat this chicken finger?
Yeah.
Okay.
Good job. Thank you.
The cylinder head would be the closest part, yeah. Ando, I can't help this, man. She handed me. I have to eat it now. I'm sorry. A warning. You don't warn Brima, okay? You don't have that privilege. Frankly, neither do I, but... Thank you, cooking. Okay. All right. Yeah, I guess the best way to describe this would either intake manifold, basically. Intake manifold or intake port on the head. That's probably the right way to say this. And I thought you were in the lab. Yeah, I wish. I am in mission control, though. Does that help? I got all my friends here. So yeah, I mean, if I had to say that this is probably, I mean, like, okay, it's hard to. So like a rocket engine, so like a car engine has your intake and your exhaust valves, right? Because you need to make a sealed combustion chamber, right? You make a sealed combustion chamber. A rocket is basically, with a rocket, you don't have those valves. You don't have that. Fuel and oxidizer is being put into the engine at all times. So it's basically like, it's not like a cylinder head because the cylinder head has intake in the exhaust. The cylinder head on a car is the most like a combustion chamber on the rocket. You have stuff entering and exiting out of it. You have fuel and oxidizer entering it, and you have exhaust exiting it. That's probably what it's the most like. That mixes the O2 and the fuel, so it's more like the carb. Nah, see, caveman, this is where the analogy breaks down. It does and it doesn't. This mix is fuel-rich bipropellant and then oxidizer, because it's a stage combustion cycle, fuel-rich stage combustion cycle. So one side is stoic, the oxidizer side is stoic, right? And the other side is fuel-rich for cooling purposes. That was the idea. The idea is that they would use a fuel-rich stage combustion cycle on the shuttle engine and use the hydrogen to keep everything cool so they could reuse the engine more. That it kind of worked out. Maybe we should just compare it to jet engine parts instead. It's not even comparable to that. In 5 weeks' time, this will host the Formula One race. Yeah, no, it won't. No. Forge, I don't know, maybe. Does it have a pump like a turbocharger section? Here. Yes and no. All right, so here. Let me just get a nice high-res picture. Okay, so with an RS-25, you have fuel coming in one side, you have oxidizer coming in on another. All right, so basically the fuel splits up. It splits into two different pathways, okay? So up here you have the pre-burner, okay? Hydrolox comes in, or hydrogen comes in, it goes down here, it goes around. It goes through the high-pressure fuel turbo pump, okay? That high-pressure turbo pump is being actuated from the pre-burner. The pre-burner is a little bit of liquid oxygen injection on the hydrogen side power head, okay? The reason why it does that is because the pre-burner is running extremely fuel-rich. If you notice, the oxidizer line going into this is a lot smaller, right? It's a lot smaller than the fuel line going into this, right? So the hydrolox comes in, goes through the impeller, then it goes down here through these valves, and then it goes through the liquid hydrogen goes through the engine and keeps the nozzle cool. And then part of it splits up and goes over here, right? Part of it splits up and goes to the oxidizer pre-burner, and part of it splits up and goes to the fuel pre-burner. And then there's a third outlet pipe on the nozzle where it goes to your low pressure hydrogen turbo pump. That spins an impeller, or that spins a turbine wheel, which turns an impeller, which pulls more fuel in. And then from there, look, you have two ways for fuel to enter here, okay? Off of that, it goes in, and the pre-burner coupled with the kind of exhaust from your low-pressure turbine turns the big turbine right here. And the exhaust from that big turbine is extremely hydrogen-rich. You run way... It's hot gases, but it's hot gas hydrogen. So it's very, very... If you combined it with oxidizer at this point, it's extremely flammable, right? Because you have vaporous gases, basically. Like, it's the byproduct of a small little combustion chamber in here, right? So then what they do is they take that extremely fuel-rich hydrogen or hydrolox mixture, which is very hydrogen-rich. There's more hydrogen than oxygen. And then they shoot it into the main combustion chamber, right? That's what this thing does. That's this thing. You're looking at it upside down, right? Where the heck is the picture? Come back. That's what this thing is. Those three right there. The red caps are from the two power heads, or the two turbo pumps, right? And then the combustion chamber attaches right here. It goes through an injector plate right there. It atomizes again with more oxidizer, right? They hit it with more oxidizer, and then they have a oxidized, well, it's not oxidizer rich, it's stoic. So stoic, oxidizer, hydrogen mixture right there. So you have fuel rich over here. You have stoichiometric, which means equal parts hydrogen and oxygen, right? And then you have another injector for oxidizer there. It atomizes all of that in there, and then it blows it out the bottom, okay? Now, the oxidizer, right, you keep in mind a couple of other things, not just the oxidizer. There's a tap off here for autogenous pressurization. There's the GOX line and the GH2 line, gaseous oxygen, gaseous hydrogen. Those go back to the external tank. It's gas that goes to the ET to keep the external tank pressurized for tankage purposes. Basically, they fill it up with gas as they're draining liquid out of it to get the liquid to kind of stay in one spot at the bottom of the tanks where the pickups are. Long story short. And the tank is the primary structural carrier of the entire shuttle. If the tank was depressurized, it would just be like a floppy balloon. You don't want that, especially during launch. That would be bad. So the oxidizer basically does the same thing, but the oxidizer splits. So oxidizer comes in, right? It goes down through here. It goes through the turbo pump, and then most of that oxidizer goes back. It gets injected over here. Most of it gets injected. Some of it goes up through the pump. That's a fuel pump right there, or an oxidizer pump. It goes up here into the low pressure oxidizer pump, and that turns that pump. The oxidizer gets pushed through here. It makes pressure, and that turns that thing. And then it gets re-injected back in, right? And then, from there, some of it goes out through and gets injected into the preburner. And this preburner right here, if you notice the diameter of the pipes going in, they're almost exactly the same, okay? So this is running stoichiometric, or very efficient. The preburner burns a little bit, but they use the preburner to spin the turbo pump, right? That's what's turning this thing. These are turbine blades, and the explosion turns those like you blowing on a fan, and that's what turns the pumps, right? And then this goes in here at stoichiometric. So you have stoichiometric, pure O2, right? And then hydrogen rich over here. When you combine hydrogen rich, stoichiometric, and O2 rich, or just a pure O2, you get a stoichiometric ratio in there, and then it blows it out the bottom. You basically get the ideal amount of hydrogen and oxygen for a nice efficient combustion. It's part of the reason why the RS-25's exhaust is so ridiculously clear. You can see right through it. It's very efficient. So the preburners turn the high pressure turbo pumps. What powers the low pressure ones? A tap off. It's called a tap off. Not in real. It's not a tap off. It taps off. A tap off cycle is a little bit different. So check it out. With the fuel, you have fuel going through these valves here and through the nozzle at very high pressure because it's post fuel pump. So it's like on a fuel injected system on a car mile. Very similar to that. Only this is moving a lot more fluid, a lot faster. Some of that goes into the two preburners. Right? Some of it goes into the two preburners. Actually, most of it goes into the two preburners, and then some of it goes to turn the low pressure fuel turbo pump. Now, I know what people are saying. This looks a lot simpler. Why don't you just do this over here? Why do all this? Why run one side hydrogen rich and then inject the LOX? Because that's what full flow stage combustion cycle is. With Raptor, if you drew a line down the center of this and mirrored it over this side, that's what Raptor does. That's the difference. Shuttle guys, the shuttle engineers, the tech just wasn't there to be able to figure it out. Makes me wonder which turbo pump starts with the RS-25. Which one starts first? Look at our RS-25 igniting. Should tell you everything you need to know. So the hydrogen is expanded from the heat transfer from cooling the nozzle, so it has pressure to spin the pump. Yep. Once again, it's not hard to understand what this does. It's hard to do it. I know how this works. I can tell you how that works. That's no problem. Dude, if you put the engine in front of me, I could probably trace the lines. Does that mean I could build one of these things? Man, hell no. Does that mean I could put it together and have it work correctly? No, absolutely not. No. That's the part that's hard to do. Yeah, that's the whole, it's not rocket science. That's where that phrase comes from. It's easy to understand. It's not too complicated stuff. There's just basic thermodynamics going on here. These people are geniuses for coming up with this stuff. Guess why they call it rocket science, right? Yeah, no, it's this stuff. the principles of operation are super simple. You're taking fuel and you're taking oxidizer and you're making it do stuff for you. It's no different than a car engine or a jet engine. Same thing. You're following basic thermodynamic principles here. You know, you take oxygen, you take hydrogen, it's really cold, you combine them, you blow them up, you get a really efficient explosion. I don't think the RS-25 is stoic. I thought it was 2.6 H2s to each O2. Well, Max, what part are we talking about here? I know that the hot gas manifold here, this, because it's fuel rich. That's fuel rich right there. I think this is fuel rich. This one might be a little bit fuel rich just because of what's stoichiometric for hydrogen. I don't know. I don't know off the top. The stoichiometric, or basically stoic in chemistry, is the ideal amount of like liquid fuel and oxidizer that you need to make the most efficient explosion. Stoichiometric would be 2.1 H2 to O2 to make H2O. There you go. The stuff that's coming out the nozzle. Stoichiometric H2 would be 2 H2 to 1 O2 to make water. And the shuttle engine does make water. Yeah, wait, why would they run hydrogen rich out the nozzle? That makes no sense. It's got to be stoic coming out of it, because then they'd just be leaking hydrogen gas everywhere out the bottom of the engine. But then again, hydrogen gas does leak whether you like it or not. You know, it's really inevitable, right? It's free hydrogen. I mean, they might run a little hydrogen rich just to make sure that you get a nice efficient explosion. And I know that they do run fuel rich. The shuttle engine runs fuel rich. The reason why they wanted to run fuel rich is because it keeps everything nice and cool and prevents the rocket from melting itself. So you know it's running fuel rich because it uses the liquid fuel for cooling. It's a really smart thing to do with hydrogen because hydrogen is extremely freaking cold. Colder than liquid oxygen. Almost liquid hydrogen. Hydrogen exists as a liquid near 0 Kelvin. Yeah, pretty crazy. Never run stoic, rocket guy. Just a little bit on the fuel rich side. That makes sense. I mean, that's what Max is saying. So yeah, I guess. So rocket guy, answer me this. What's coming out of here? What's coming out of the LOX preburner? Would that be stoic, or would that also be just a little bit on the fuel rich side? Stoic's way too hot. So, I'm thinking, so Rocket Guy, what I was saying, and you tell me if I'm wrong, dude. I don't care if I'm wrong about this. I want to learn this. I want to make sure I should know this cold, to be honest with you. So, what's coming out of here? Out of the LOX power head? Or into the LOX power head? What's this? Why do they have more O2, more LOX being put in right here? This should be hydrogen rich. That should be fuel rich, like way fuel rich. This should be stoic. And that's extra O2. That's the only way that makes sense. Or, if this is fuel rich and that's fuel rich, and then you hit it with oxidizer, that explains a little bit. You're running fuel rich out the nozzle as well. It's probably fuel rich to protect everything from O2. Both turbines burn about the same, right? No, granted, they don't. The hydrogen one there's differential RPM in your power heads. This is why you have two separate power heads. If you look at any rocket engine design should be able to tell you should be able to tell what type of fuel it is just by looking at it. When you have two separate turbo shafts like this, that means you're delivering more than the other. The reason is because when you have two, that means basically that they need to operate at differential RPM. One needs to spin faster than the other to deliver the fuel mixture that you're looking for. Extra H2 is coming from the nozzle cooling. Yeah, I suppose, yeah, I suppose it would condense on the inside of the nozzle, wouldn't it? Does that? Wait, is that how that works? Hold on a second. I thought they used basically the metal of the engine as a thermal medium there. Are you telling me the hydrogen that goes into that nozzle condenses on the inside and film cools the inside of the engine? And then the gaseous hydrogen leftover mixture goes and turns that low pressure turbo pump? Both pre-burners would burn fuel rich. Got it, Rocket Guy. Okay, so I got that part wrong. Every other part I got right. Okay, cool. Sweet. What about oxidizer-rich engines? Oxidizer-rich engines run on a single turbo shaft, Synerd. Well, like an RD-180 or an RD-170? Are you talking about oxygen-rich stage combustion, right? Yeah, they... Do rocket engines have carburetors? No. But the rocket engine is a carburetor, Flykin. Look. A rocket engine is just a Venturi. Look. It's a Venturi. I'm telling you. This is why I reference cars all the time. All this stuff is connected. It's all the same stuff. It's just being applied differently. I was going to say, Shaw, I don't think that does that. No, the H2 doesn't go into the nozzle from the nozzle cooling. It just goes up to the combustion chamber and it's injected like other gases. Okay, cool. That's what I said at the beginning, Max. I don't know if you were here for that part. No, Jupa, it's not. I often say that I often make references to cars left and right. One, because I love cars. Cars and trucks are cool. I like working on cars. It's my favorite thing to do, aside from spaceflight. But the principles are all exactly the same. The rocket engine right here, this part. See that part right there? Carburetor. Literally the same thing. Only your jets are longitudinal instead of radial. So instead of a jet hitting the Venturi from the side, they hit the Venturis from the top. It's the same thing. But, you want to know a crazy part? SpaceX's engines, Juba thingy, and anybody here that knows about carburetors, SpaceX's Merlin engines have a radial igniter. They have a radial igniter and a radial injector. They're shooting the propellant sideways inside of the combustion chamber, like a carburetor, which is weird, man. The H2 is used for regenerative cooling. The cryos flow through the thin walls, exchanging the heat as it moves up the nozzle chamber wall. That can create hot O2 to use in the pre-burners. Or hot H2. Yeah, okay, Rocket Guy, cool. I got most of this right. The only part of this that I didn't get right was saying that this is stoic. It's not stoic. You can't be, and that's the part where I messed up. Other than that, I got pretty much all of this correct. I'm pretty sure I did. That's good. It's good. It's not every day that I just go over this plumbing off the top of my head, even though sometimes. Is there a diagram similar to the RS-25 that's for the BE-4? Sure. Yeah. The only reason we're talking about it, Rocket Guy, is because Aerojet Rocketdyne delivered Powerhead serial number 7001. This is an RS-25E. RS-25E engine. Basically, they're using modern manufacturing to they're basically ruining the margins on the RS-25 because it was designed for reuse, and making them single use can bring the costs down. And also using modern manufacturing, right? You know why the extra H2 increases specific impulse, right? That's a fun thing to teach people. I don't know the technical definition, Max. I know that, having the extra H, if you only put hydrogen and oxygen in there, there's only certain things that can happen when you blow it up. It's a lot simpler of a chemical equation. Yeah? Am I in the ballpark there? Last, please. Okay. Okay, so wait. A Venturi works by moving air and pressure. How does it atomize stuff when it's not moving? Sorry for the dumb question. So, Flykin... Okay, alright. A carburetor... This is the same shape. The throat of a rocket engine, this part right here, is the same shape as a Venturi on a carburetor. However, with the Venturi, you're not the fuel isn't delivered in the throat of the rocket engine, okay? All this is designed to do in this right here, in rocket science, this is called the convergent divergent nozzle design because it gets small and then it gets big. Engineers, they're not very good at naming things. Okay, this rocket engine converges and diverges. What are we gonna call it? A convergent divergent design. Good plan. All right, cool. Sweet, man. I'll see you later. The fuel gets atomized up here on the injector plate. Now, Flykin, remember when I said rocket science is harder to do? How do you atomize fuel? You need low pressure to do that. How do you atomize fuel in a combustion chamber that's at 100 bar? Well, like I said, remember the part where I said rocket science is hard to do? There you go. That's why we never see injector plates, because nobody wants to peep on how you do that. Because once you figure that's one of the big things. You figure that stuff out, then you're good to go. And I know now that I said it, there's going to be a bunch of people here. Well, EJ, you could just do this, and this, like a Tesla valve. Could you? All right, sweet, go and do it then. Oh, wait, don't. You'll get arrested. So what happens is it takes the gases here, right? It takes the gases that are expanding, and this part right here works more like the part of a car engine where it pushes the piston down on the power stroke. But instead of like a car engine pushing the piston down, okay, to create mechanical work, all right, this just pushes the exhaust gases out the bottom, but it pinches them. It pinches the gas. It's kind of like an impingement system on a firearm, almost. Not really, but it impinges right there in the throat. And the gases get accelerated past supersonic. That's another important part. You have high pressure here, extremely high pressure here, and then the result from that extremely high pressure gets blown out the bottom. That's really important to understand. Yeah, Synerd, right? All right, Max, let's see. What's your definition? Okay, so ISP is based on exhaust velocity, right? Yes. And lighter atoms have a higher velocity for a given temperature. So if your rocket is burning at 2000 C and its exhaust is pure hydrogen, its exhaust velocity is 2 times faster than if it was pure water. A la nuclear engines, right? Gotcha. You say don't, but why can't I? What allows Elon? Is it money? I haven't, Stormy, not yet. No, it's not money. You guys really want to do this? Go present your design to the Space Force or to NASA for a certain competition, and they'll award you funding. You gotta. NASA puts out these proposals all the time for stuff that they want or need for rocket engines. That's how SpaceX got a contract. It's just like if you want something to fly above 1,000 feet, you got to talk to the FAA. It's the same thing. There are reasons why you can't just go make a liquid fuel rocket engine in your garage. You're playing with fire. Fast fire. Which is even more dangerous than regular fire. Oh, so when you throw fuel down the injector plate and then light it with a spark igniter or something, it goes out the throat and then it pulls a vacuum out of the injector plate? No. You're overthinking it. The injector plate spits fuel and oxidizer. Think about it like a fuel injector on a car, but it's spraying liquid oxidizer. Because remember, unlike a car, your oxidizer and your fuel are both liquids, instead of just a car, which is naturally aspirated, right? Which uses atmosphere and liquid fuel. See? Too complicated. Those grants, usually called SBIR for startups, are opening up in the next month or two. Yeah, that's the way I'd do it if I was going to build a liquid fuel engine. Claude Boy, yeah, see what Rocket Guy said, but you're also right. And Flykin, rocket engines work because your fuel pumps are what's delivering your fuel. And so, okay, with a car, all right, it's right? Spark plug needs to tick on every time because after the spark plug goes and the explosion happens, the piston has to push up and open the exhaust valve and push the exhaust gases out, right? You don't have that with the rocket. All you got to do is light it once. Think about it like a propane grill. I tell you, boy, that dang old propane grill, I tell you, is real good. All you got to do is ignite it once. That's it. And then it stays on. You just spray fuel literally into the fire. Spray atomized fuel into the fire. But how do you get the fuel how do you get the oxidizer and the fuel atomized? That fire is exploding. And it's exploding at the injectors. See what I'm talking about? Difficult. It uses a Venturi to accelerate the gases, Flykin. A carburetor uses a Venturi to accelerate and quickly decelerate the gases to get a pressure change to atomize the fuel correctly. Hey, Vixit, you like space. But it's all the same stuff. I mean, it's all the same stuff, man. I mean, guys, like, okay, rocket engines like this. Okay, look, check this out. You have your pre-burners. Your pre-burners explode, right? And then they explode into a turbine wheel. That turbine wheel starts spinning. If you have a fan and you blow on the fan, what does it do? It turns the fan, right? Same idea. That explosion right here turns the turbines, which turns the fuel pump, which in turn brings more fuel into here. Okay, as long as you can keep delivering fuel and oxidizer, this thing will just keep going. Right? And once again, as Rocket Guy and what I was explaining before, this is extremely fuel rich. There's a lot of hydrogen in here, not a lot of oxygen. Look at the diameter of the pipe that goes in here, even on this diagram. The diameter of the pipe there and the diameter of the pipe there. There's a lot more hydrogen than there is oxygen. So they hit fuel rich here and fuel rich here, and then they hit it with more oxidizer in there, and then it's still running fuel rich. Look at how much hydrogen is going in. I mean, see, this makes a lot more sense now. Look at how much hydrogen is going in on either side comparatively to oxygen. There's a lot more hydrogen in there. But this is the part where I was blanking on. You have to run hydrogen stoichiometric, or else it'll melt the rocket engine. It won't rocket engine anymore. That's for sure. It won't run fuel rich. It'll run engine rich, just like that Raptor that one time. I bet injector plates work by changing the pressure of the fuel to get it to mix correctly in the high pressure of the combustion chamber. I bet you that's how that works. Yeah, because you got to remember, it's not just spraying fuel. It's not spraying oxidizer. You have to spray them to atomize, and then that needs to hit the flame. That's hard to do. Don't attack me like this. I'm not attacking you like this. It's a hard thing to understand. Now, Flykin, what's really going to blow your mind is how do you prevent it from going back into the injector plate and not out the freaking, not out the bottom of the nozzle. Yeah, that's what I mean. You want to get detailed with this stuff. Not even I'm sketchy on it. It's hard to do. I understand the basic principles, but I ain't going to go and build one of these things. What are you, crazy? Are injector plates your daily bread and butter? Scott Manley actually has a pretty good video on injector plates. But yeah, that's pretty closely guarded stuff. It's proprietary, and that's the kind of stuff people don't like. That's the real ITAR stuff. That's the stuff that people don't want you to... You don't want to see that part. That's like really, really controlled. To blowback, you just make the pressure on the inside higher than the pressure on the outside, i.e. flamey stuff down. That means you're going to need to deliver fuel and oxidizer in the case of Raptor at more than 300 bar. 300 bar is extremely high pressure. How do you get something at 300 bar to atomize? See? Gets complicated. How's Duff Enough? I haven't touched it in a week because we had the nor'easter. It got rained on like crazy, or knock. I have to go see. I don't store it up. It's not at my folks' house, and it's not at my apartment. It's at a buddy's house. I gotta go check on it. I'll probably do it this weekend. But yeah, it's literally... I parked it like a week and a half ago, and I disconnected the battery and everything, and I just kind of left it there, and it's done nothing but rain basically every day since. Yeah, so this weekend... on Sunday, I'll probably go and get it and drive it around a little bit. Cool it. Cool it? You know that cooling things changes the pressure, right? No? Is there somewhere we could see an injector plate? Sure. You can see the shuttles. Here, you want to see it? Here's a guy machining a shuttle injector plate in the 70s. Take a look. Boop. Nah, it's alright, Onog. It happens. Yeah, there you go, Hell Hydra. You got it. We should have more rocket engine nitty-gritty conversations. This is fun. Alright, cool. By the way, the KSB2 vid release for yesterday is for real now. Hey, NASA man, what's going on? Wow, it's 6:45 already. Okay. Yep, see, it's dripping the coolant on there. Make sure you don't warp the metal. See, this is the BPM-5 injector plate. Swirl injectors. Cool. I guess CNC wasn't invented yet. In the mid-70s, KS? I don't think so, no. It's crispy, yeah. I mean, Hellfish, those turbo, the turbo pumps on the Raptor engine, I mean, once again, that's the thing. It's a hydrostatic bearing on the turbo pumps on Raptor that allows them to spin extremely fast. I don't even know what the RPM on those things are. I've guessed it's above 50,000, but I don't know for sure. I have no freaking clue. But the fact that they can spin that high is what makes all that pressure and makes them able to deliver more fuel and more oxidizer, and more fuel and more oxidizer in your combustion chamber equals a bigger bang. That's right, Flacken. Mm-hmm. Show the diagram again. All right. That was a test injector plate to test the swirlers for the BPM 100 engine. Yeah, those are swirl port injectors. Yep. Delivering the fuel and oxidizer in a rocket engine, once again, that's one of the more difficult parts, I would say, from my understanding. That stuff gets complicated. Anyway, good conversation. Yeah. Peep it. It's pretty cool, man. I mean, I don't know the exact RPM, Hellfish, but to make 300 bar chamber pressure, which is, I've been getting whispers that SpaceX did it for a sustained period of time on a Raptor for the Raptor 2 design. That's what I've been hearing from folks. But once again, that's my sources say thing. Elon has said multiple times that that's the end goal. I just heard that it happened. Those things got to be spinning real fast, like real quick. Okay, so I figured out the basics of how an injector works. Low pressure inside the ejector allows atomization at lower temperatures, then that's yeeted into the combustion chamber, bang, zoom. Something like that. It's like, and if you see, here's the thing. You're like, well, what about this? Well, what about this? Hell if I know, man. If I knew, I'd be freaking making my own rocket engines and launching stuff into space for NASA. I don't freaking know. Rocket Guy probably knows. I know. I can only tell you how it works. I can't tell you how it's made. Frick if I know, dude. I have no idea. I don't know. That's what I tried to tell you guys. I understand how it works. That's not that hard. Doing it is the hard part. I'll take an injector plate for soda. I mean, RP1 probably isn't the tastiest, although it's got more zip. Yeah. Indeed. New project, small test stand, only hydrogen peroxide nitrous engine. Yeah, that's how you get people coming to your house, man. I don't want to do that. Yeah, that's not a good idea. Yeah, I don't want to do that. Why is making your own rocket engine against the law if it's your own design, I mean? It's for the same reason why you know, like, can't own a nuclear weapon or something. Yeah. It's like in rockets, the reason why rockets are so heavily regulated is because of a law that has to do with the international trafficking on arms regulations kind of standards that the U.S. has. It's basically proliferation and export control on rocket technologies. The reason why there's such proliferation with rocket engines is because if rocket engines were as easy to build and make as like a car engine, you know someone would abuse that and use that to deliver something to somebody that they don't like. Long story short, the U.S. doesn't want, like, North Korea or Iran or anybody that's going to launch something at us or an adversary, right? We don't want adversaries getting this type of technology, even though they probably already have it, but that's another story. That's the idea. That's why rocket engines are so heavily safeguarded against. Rockets and guidance systems, because you don't want somebody just making a ballistic missile in their backyard, which if you had a machine shop, you probably could, but that doesn't mean you should. That's going to get the ATF at your door real fast, man. And probably a couple of other alphabet agencies. You'll have enough alphabet agencies at your door to spell the entire alphabet. That's correct, NASA man. That and it's proprietary, right? Yeah, I mean, it has something to do with that. Yeah. Automotive injectors aren't strong enough, Hellfish. With an automotive injector, you could make a rocket engine, but it wouldn't be able to get off the ground. The rocket engine would have like 0.2 TWR. The guy here in Sweden tried to make a nuclear reactor in his home, and yeah, a few guys showed up and said hi. Yep. What the heck was that noise? Oh, it was the Roomba. The Roomba's banging up against my door. But every factory I toured in Cali literally said ITAR in bold letters on anything they didn't want us seeing, with a giant black curtain. Yep. So today the alphabet turned up at my door. Yeah, you don't want that kind of stuff. That's no good. Anyway, so let's keep going here. So Crew 3 is pretty much ready to go. This is going to be annoying. There was a press conference this morning, and Kathy Leaders, the head of NASA's Human Exploration Operations Mission Directorate, basically person in charge of sending people into space at NASA, whether it's commercial crew or on NASA's own rockets, that's what she does. Basically said that the conditions for launch are looking good, but the recovery area for the first stage is not looking good, and that's decreasing the probability of go for the flight for Crew 3. So pretty much standard. 80% favorable. So we're still looking good for a launch on early Sunday morning for Crew 3. Once again, while I have everybody's attention here, Hunt the Streamer tomorrow is going to start at the end of Space News at 6. We're going to play GTA for the mid-hour slot because Crew 3 coverage starts at 10 p.m. on Saturday night. So we're going to do how tomorrow's schedule is going to go. Minecraft, Space News, GTA, Hunt the Streamer, and then Crew 3 coverage. So hopefully we do get a launch. And Sunday is your birthday. Well, happy birthday. I think they did sign off on the new toilet bee money, yes. So, yeah, we got early Hunt the Streamer tomorrow, so it's going to be during the day. You know, a lot of people say, oh, why don't you do Hunt the Streamer during the day? Well, okay. Fingers crossed. If not, it's a 72-hour turnaround. And yes, they signed off on it. Boom. Yeah, Gerst signed off on it. Nice. I'll be honest, Sawyer, it's still super funny to me that SpaceX poached Gerst from NASA after, well, they didn't poach him. After Jim said, nah, get out of here. It's not going to be fun looking under the floor of Crew 2. Yep. Yeah, I'm happy that SpaceX picked him up. That's... Yeah. Guys, a lot of technical expertise on flying people into space, I would say. Hey, Jordan, what's up? Doing my random pop-in. 6 months left in the core. Off to renewable energies. There you go, man. That's good. Cool. 6 months left. There you go. Oh, you don't want to sign on another tour? Come on, man. No. That's what the recruiter's probably saying, right? They're like, oh, come on, you want to sign off? You want to do that right now? No, I'm good. Good to see you, man. 17-month resub. What if I build an engine on Mars? ITAR can't get you. If you can build an engine on Mars, the ITAR people wouldn't be like, you're under arrest. The NASA people would be like, hey, how'd you do that? Yeah, right. How'd you do that? Crew seemed happy at wet dress rehearsal. Here, let's take a look. Oh, hello. You sound like my higher-ups. Hope all is well. Yeah, everything is good, man. Yeah, baby. Caleb Barron, Roger Chari, Tom Marshburn, and Matthias Mara. Crew 3. Third SpaceX crew to launch on a Falcon 9 to the ISS. With their rocket behind them. Using a brand new Dragon capsule C210 or C210. A brand new upper stage and first stage 1067.2. One-time reused stage. Two rookie astronauts at the same time, man. Excellent. So, the Shelton family has been... This is coming from Brendan Byrne. The Shelton family has been sending roses to mission control for every shuttle mission since 1988. Now that NASA is launching astronauts from the U.S., again, thanks to SpaceX, the bouquet hath returned. Yep, there we go. Excellent. Capsule name, Enduro. That's right. Cool. So, we got a little bit of Russian news here. Let's see what we got. I got Russian news, and then I got Starship news, and then after that... Actually, you know what? After the Russian news, Sawyer, I think you will show us some pictures of your exploits. That'd be good to see, I think. Okay, I think I got all the Russian news here. There we go. So, a last bit on the thing about Crew 3. Look at this picture. Cool, I'll be back in 2 minutes then. Crew is also having fun in the arm. Yep, yep. Interesting. Yep. Happy Gilmore jersey check. Bro. Come on. Come on. Come on. You think this is a game? I mean, it is. It's called hockey, but... Alright, so, let's see what's going on over here. Let me just move this stuff over. Nope. Why does moving it to the end of the monitor make it a new window? Who thought that was a good idea? Stop it. Okay, here we go. Thank you for your service. No, you don't. No, you got that the wrong way around, man. You got that wrong way around, mate. All right, so na Kosmodrom Vostochny Zaverwe? Nope. So construction is, they're working on the construction for the rocket Angara, all right? Zavation.
No throttle up.
Dude, the W is SH. That all, and then the W with the little squiggly line on it is another different letter. Why you gotta do that? Why you gotta make the letters look the same, Vasya? What the hell is this? Frame construction complete. Yeah, there's the launch plate. Okay. Onya Sostoid is? Hit AJ with a no, you. In Soviet Russia, service thanks you. Yeah, that is, right? So it's 16 to number 40. That's talking about the sea route, how it was delivered, right? Is that a launch site or a motherboard? Yes. $43 tons each. 43 ton. Tonnable? 16 parts. Each parts is 43 tons. Okay, got it. Yep. All right. We are proving once again that EJ sucks at reading Russian on stream. Cool. Tony. Oh, okay. Why wouldn't this be a backwards N though? Like that. Doesn't that make the I? I thought this was no, I forget. Is there any word on that telescope that's going to be put in space soon? It's down in Kourou being put together, being assembled on the rocket that's going to deliver it, Jordan. It's going to happen sometime by the end of the year. Just use the translator. How the hell else? No, the translator doesn't teach you anything. Some gamers in Russia don't figure it. We use English letters for usernames like the rest of the world. Yeah. Alright, let's keep going. Completed installation of the launch pad frame for the rocket. It consists of 16 parts, 4 corner parts at 43 tons each. Each middle ton weighs 23, and 4 pylons, each weighing 52 tons, now installed in the final position. They're talking about this, the green part right there. Is I? So wait. Oh, E. So it's like it's the backwards N is I, right? It's like I'm doing this, right? Okay, I'm gonna make it worse. And the other one is E because ton, right? Tony. Yeah, okay, I got it. It took me a second. I got it. Just have to freaking remember the damn thing. Kind of looks like a stadium. I mean, I'd sit and watch from right there. Would you? I'd bring headphones. You'd probably want some headphones. I don't want first row seats. No, we don't need that. I don't want that. So there's the plate thing is what they're talking about. There's the corner pieces, right? And then there's the center pieces. You could see that there's 4 kind of spots here for the boosters, and then there's one single spot in the center. Now, because this looks like a freaking motherboard, you can kind of tell where the service structures are going to be. Angara has 2 service structures. It usually has twin fixed service structures, twin FSS. There's one here, and there's one here. And then they don't build anything over the flame ducting right there. They have baffles in the flame trench. You can see that they're working on them right there. There's baffles in the flame trench to help kind of break up the flames, and that's where the sound suppressors are as well. And then it blows out into this area here. Yeah, see? Look at the baffling that they put in the trench right there. See that? Interesting. Huh. Yep, see? That's where center core is going to go, and then the side cores go 1, 2, 3, and 4. So you can launch with up to 5 boosters on the side. Think kind of similar to what Falcon Heavy does. Falcon Heavy can have 1 or 3 boosters. Angara could have 1, 3, or 5. Angara in the Russian space program, it basically serves a similar purpose, as like Atlas or Vulcan or Delta. It's kind of like that. It's the Ministry of Defense really likes this rocket, and that's why it's a thing. It's just thermal paste. Yeah, look at that chipset. That chipset is really nice. Cool. All right, next bit. Rakietnyo Kosmikieni. What the hell is the U with the squiggly line? Oh, whoop, whoop. It's TS. Center. Oh, it's center. Space Rocket Center progress. See, some of the words are pronounced almost exactly the same. It's just that the letters are different. EJ smart. Yeah, smart as a friggin' brick. That's what I mean. I just gotta sit here and keep doing it. I'll get it eventually. So this would be like siento. Siento. Right? Kind of like that. Duolingo in your bathroom time. Yep. You have to like when you try to pronounce Russian, you have to put the tongue on the top. Put your tongue on the top of your mouth. Raketnyo Kosmikeni Center Progress. You have to put your tongue up there and then try to say it, and it comes out right. I don't know. Here, let's listen.
Ракетно-космический центр «Прогресс» завершил ряд статических испытаний топливных баков первой ступени перспективной ракеты-носителя «Союз-5». Конструкция одного из 2 опытных образцов была доведена до разрушения внутренним испытательным давлением. В ходе испытаний были подтверждены заявленная прочность и жесткость элементов конструкции и в целом правильность конструкторских решений.
So, what are the Russians up to here? The guy says basically at the beginning that workers at the Space Rocket Center Progress are working on Soyuz 2, or Soyuz 5, excuse me. They're working on Soyuz 5 and working on building the test articles for Soyuz 5. And one of the test articles was used in a pressure test right here where they filled it up with water to see how much this thing could take before it went. Destructive testing calculations were verified. Now, see, that's good engineering right there. I'll tell you right now. If you don't, in rocket science, you got to think kind of backwards. You got to do the math out, right? It's not like you put the thing out on the test stand and then you pressurize it and then it blows up and you write down where it blows up and you say, okay, that's the failure point. No. You do the math out. You do the math out and you have your math say when the failure point is going to be. And then you do your destructive testing. You use the math as a datum, all right? This is what you think it's going to do. And then you test, and like when it pops, you want to see how close your math was to the actual destructive testing. The closer that the closer that it is to your math. If your math says it's going to fail at this point, and it fails at that point plus or minus like a few seconds, you're good. You did the math correctly. When you're testing rockets, you verify results. It's not like typical scientific method where you have an experiment and you have a control. Okay? Your control group with rocket testing is the math, all right? But you don't want a different result. You want your testing results to reflect exactly what the control group is. Destructive. That's what it means when it says calculations were verified. It doesn't matter if it's Russian, doesn't matter if it's American, Chinese, European, whatever. Everybody tests this way because that's the way you got to test. Because how do you know mathematically when it failed if you just put it out on the pad and blew it up? I mean, that's funny, right? And that's very Kerbal, right? In Kerbal, that's how you test things. Just put it out and see what happens, you know? Trust but verify. Yeah, basically that. Boeing and SLS tanks did the same thing. They were like 3% deviation margin. Yep. 260% of rated load, rocket guy, at 3 hours. It held 260% of rated, the hydrogen tank, at 3 hours. And Boeing predicted the failure point with math within a 3% deviation, which is pretty friggin' good, man. That's pretty friggin' good. Ugh, sorry. You got a burp. That's interesting that it failed. I mean, look at that. Oh, hello. Look at that. Dude, that thing cracked a plate, which is unbelievable. So if you look, this common bulkhead for Soyuz 5 is made out of metal pieces that are pie cut. They basically pie cut the metal pieces into something that looks like a slice. They chop the top off for where that circular part is, and then they put them on a jig and press them like this, and then take a bunch of those pieces and put them together all around. It has vertical welds on it, longitudinal welds instead of transverse. That thing failed on a plate. See that? It didn't fail. It failed perpendicular to the welds, which is pretty hardcore. That means that thing is really goddamn strong. Yep. That means, yeah, exactly, Signer. You saw the same thing you saw the same exact thing that I saw. That's good. That's good design. You don't want it failing on the welds. You want the plates failing, because the plates are, if the plates are failing, that means the welds are strong enough to hold this thing together. And knowing the Russians who know what they're doing, they probably way over-tested it. As a former welder, that test couldn't have gone better. You want the base material to fail. If the weld fails, your welder did a bad job. Yep. There you go. Good stuff. Good testing footage there. All right, next bit. I think, okay, that's the same thing. NPO Energomash. Hey, I know what that means. So Nargomash is working on the testing the rocket engines for progress for Soyuz 5, yeah? It's either testing or manufacture, I'm not sure. Raketny. RD-171MV, yep. Yep. There you go. The engine passed firing tests, which confirm the quality of the design and technical solutions to the engineers. That is the single most powerful liquid fuel rocket engine ever devised. Right there. Nothing has flown that creates more thrust than this that uses liquid fuel. Solid fuels are the solid fuel rockets on the space shuttle and SLS are the most powerful rocket engines flown. The most powerful rocket engine ever tested was the Castor 260, which was a 260-inch wide solid rocket motor that NASA wanted to use for Saturn I's first stage. This thing makes more thrust than the F1. The Saturn V F1 engine is the most powerful liquid fuel single nozzle rocket engine. The Russians use 4 nozzles with this thing for heat purposes, basically. You spread the heat over 4 nozzles, it's more surface area. Yeah, this is a 171. Yeah, MV is modernized variant, right? That's what MV stands for, correct? I have to ask. Fun fact, thing is still in the ground. What is it? Modern. I'm not gonna try it. Modernizia. I forget how it's said. I forget how it's say. Nice. I thought it was for combustion stability reasons. They couldn't get larger chambers to be stable. I mean, there's multiple reasons, Synerd, to be honest with you. Heating is one of them, and yeah, it's hard to sustain combustion in a big engine like that. But yeah, also heat, man. That's cool. I mean, Soyuz 5 is coming together a lot quicker than we think it is. Is there a vote up for the future of KSP? Nope. Not yet. Nya Cosmodrome, Baikonur. Oh, it's the same word. Is the W the SH? That's the SH, right? No. Zavoroshilos? Man, that's a Greek word. I've never seen one. Okay, so this is this would have been vacuum testing. That's the vacuum test chamber. They tested the Prichal module, which is another that circle thing that looks like the Space Core from Portal. That is another module that's going to be attached to the ISS. They launch it on the front of a Progress spacecraft. This is a special purpose Progress craft. That's what MYM means, but I forget what it means in Russian. Don't. I got this. Evtomatzirov, I always screw up at the end. Evtomat, AK-47, good enough. Good enough, that's fine. Automated control of the high requirements of the tightness of the compartment. It's vacuum testing, that's what it is. Close enough. It's not, though. We gotta get it right. I gotta get it right. Gotta get better at it, man. Wait, has nobody made the Space Core jokes for that yet? You're the first one I've heard do it. Oh, I've been doing that for a long time, Synerd, since this thing was just an aluminum shell. I'm like, it looks like a Space Core. Space, wanna go to space, wanna go to space, wanna go to space, wanna go to Earth, wanna go to Earth. So this white part up at the top, guys, this is called an Uzlovoy module, or utility module. It's a 6-axis node, okay? It's a 6-axis node with 4 or 5 passive SSVPs and 1 active SSVP. What does that mean? So these are Soyuz and Oryol docking ports for Russian spacecraft. The passive ones just look like a cup. And the active ones look like a cone. See the red cone right there? Basically, you have positive and negative ports, right? This has 5 negative ports down here for up to 5 things to dock to this. And then the positive port is going to attach to the space station at the bottom of the Zvezda, or Russian science, or not Zvezda, Nauka, excuse me. The Nauka module, which is the science module. It's going to dock to the bottom of that. Bottom relative to the space station. The space station has local up, down, left, and right orientation. So it's going to dock to the nadir, or the bottom of the Nauka module. I just like saying active and passive, Synerd. Yeah, it's just easier. Because, Synerd, if I said this is a male port and that's a female port, what's chat going to do? The male port has a dangly bit and the female port has a hole. What's chat going to do if I say it like that? Positive and negative, active or passive. Let's just go with that. I find other ways to freaking say it, man. Giggity, giggity, giggity. Yeah, the ratio is right, Nikita. Mm-hmm. But yeah, chat, when two spacecraft love each other, okay? Did you just assume that, well, you can have all different types of docking ports mile long. Soyuz uses male and female. IDSS uses androgynous ports, believe it or not. So you can't play the did you just assume it's gender game with that. You can't do that with docking ports because there's androgynous docking ports. There's docking ports that can be either one. They have an active and a passive system that can deploy, so they can either receive or dock to. Yeah, I know. See why I call them active and passive and not anything else? Yeah, great. Positive, negative, active, passive. We don't need to start that conversation, man. Let's not. There's all kinds of docking ports. There's even birthing ports. Straight up. There's birthing ports. There's androgynous ports. There's active ports. There's passive ones. There's male. There's female. Hey, pick whatever you want. It's current year. Is it too late for me to retract my statement? You open the can of worms, man. MV in RD-171MV actually stands for Modified for Vostochny. Today I learned. Huh. I thought it was just modern variant, but alright, cool. Sweet. Modified. There are birthing ports, but my wife has a name to... Oh. Mr. Garrison, Wendy and I believe that was a sexist statement. Well, I'm sorry, Wendy. I don't trust anything that bleeds for 5 days and doesn't die. That was a joke. That was a joke from South Park from a long time ago. Don't kill me, please. Please. I'm kidding. Kidding. It could be whatever kind of docking port you want. I'm serious. There's all... The ISS... Dude, the ISS looks like... The ISS freaking looks like the back of my monitors for the longest time. Like, what... Once upon a time, I had monitors that converted SVGA to DVI to DisplayPort to like HDMI to get my setup to work. And then I said, screw it. It has more adapters than the ISS on it. And I said, we'll just standardize the setup. Modified for Vostochny, yet gonna be launched for Baikonur. Yeah, whatever.
Excuse me.
Hi.
Hi. Where?
We're not talking about docking ports docking to each other.
That's a really weird way for you to respond to me, and I don't know how to handle it because I had a rosé hard cider.
Oh, crap.
Where does one get baked goods around here at 7:15 on a Friday night?
You could try the grocery store.
No.
I don't think there is any place.
There's no...
You'd have to go into the city. Oh, crap. DoorDash.
I'm looking on there.
What kind of baked goods do you want?
I don't know.
Oh, no.
I just went by a bakery earlier, and I thought to myself...
We just had Chinese food.
I know. On my way to Chinese food, I went by a bakery, and I was like, no, I don't eat baked goods. Brimo is a baked good? That's false. But now, I'm laying in bed, and I've decided I want baked goods. I'm not gonna make an endless stream to get me baked goods.
That's on the internet. You can't take that back. Jesus Christ.
Chad, I haven't had any pot, for the love of God. I had one rosé hard cider.
Oh, crap.
What? It was a pint. It was only 5% alcohol.
I'm going to show you this video later. I'm going to show you this VOD.
No. No, only one. Only one, Chet.
I don't know any...
No? I can't. I have to save them.
You can't... My mom says make cookies.
This is your way. This is your mother's way of telling me to get off the stream. I'm embarrassing myself.
I am not part of this conversation. I am abstaining. I feel no positive nor negative one way or the other. Viv!
Well, Chat's solution seems to be DoorDash, so I think that's might be what we have to do.
I have no strong opinions one way or the other. Hi.
Hi.
How are you? You alright?
I'm fine.
You sure?
Yeah.
Okay.
Don't show me this later. I'll hate it.
Yep. Why don't you go get like a Frosty?
I can't go anywhere.
Oh yeah, that's right. Then why'd you ask me? You knew the answer was going to be DoorDash.
I thought maybe you would have a DoorDash recommendation.
I don't know what the hell DoorDash is. Right? Boy, do I look like I know what a JPEG is.
Cinnabon! Oh! Oh, Cinnabon. I'm gonna go see if there's a Cinnabon that'll deliver, Chat. See, I knew someone would have a solution.
Thank you, FX. What were we talking about? What if NASA reopens HLS because of Blue Origin, but then awards it to SpaceX and Dynetics? That would be hilarious, Atran. I would laugh. Atran! Continuing the sub gifted by Hokey. What's up, man? I don't think I've talked to you since. Sorry I missed you out at Vandenberg, dude. Time got away from me, as always. Adrian, how you doing, man? You just gave 5 fiancé experience for surviving that. All right. What can I spec that to? I'll put that into intelligence. Yeah. Spec it to intelligence. No, man, my fault. Don't even sweat it. It's all good, dude. We made it home. I don't know if you knew. That was fun. Good. You're moving to Vandenberg in a month. Well, shoot, man. Now I'm just going to have to drive back out there for us to hang out, bro. I know a bunch of people that live there, Atran, if you want people to hang out with. You know, I'll call my crew. You go call your crew. We can rendezvous and drive trucks around. Reverse road trip. Sorry, you can only put the points to losing your voice. Well, I'll just hold on to them. I'll just put them in my pocket there. I'll hold on to them for later. Poet, and don't even know it. Yep. Hunt the Streamer is tomorrow, Forfa. Hunt the Streamer is tomorrow starting at 6 because Crew 2 is taking Hunt the Streamer, or Crew 3 is taking Hunt the Streamer slot. Crew 3 coverage starts at 10 and goes till launch, which is like 2 in the morning. It's taking Hunt the Streamer's spot. So Hunt the Streamer is bumping KSP tomorrow. Yeah, so we got early Hunt the Streamer. You should cross the country in all the cars. Yeah. Max stamina before kids enter the picture. I got pretty good stamina. I could sit here and do this all day. This is the same. It's just babysitting. Here, look at the Space Corps. My local time, Barack. It's going to be super early in the morning for Europeans. Wait, what did you just say? I'm sorry, Pythos. I'm afraid I can't answer that. I see the Space Corps. All right. That's all I see. That's the Prichal module from Russia. All I see is the Space Corps. That's just literally. That's just a portal core being launched into space. Upgraded orbital module for Soyuz. Yeah, right. What if they just kept stringing together orbital modules?
Go and throttle up.
Rocket guy. Like, you just keep launching these things. Just keep launching Prichals, and like, instead of a perfect sphere, you make one of these like pill shaped and just keep stringing them together. Just make a gigantic freaking station that way. All these places to dock and nothing to do. You don't know that for sure. I have a feeling that the Prichal module might. Actually, this really depends on how the IAC goes. Those energy modules from the Russian segment might end up at the ISS still. I mean, it's unlikely, but they could. That'd be kind of nice. Killmeister, 47 months. Thank you. All right. Anyway. So, now, they were also saying that they want to make ROSS International like a new ISS. Kem, hear me out. Why don't we just take the Russian orbital segment, or the new Russian space station, and why don't we just attach that to Axiom space station? Well, it's already at the ISS. Yeah? 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 It's a good idea. We should do that.
Discovery, go and throttle
X, what's going on? 52-month resub. Hello, this is resub payment for you not killing me at Spa tonight. X, I'm a good driver. What are you talking about? I don't think they like the inclination, and Axiom is for tourists, right? Yeah. Kem, I'm wondering for the Russian orbital space segment. Sawyer, get teed up, by the way, if you're still here. I get launching your own space station, etc., but having it international is an excuse to keep your spaceflight industry going. The only reason I know is because that's what we've been doing for the past, however long. And, I mean, we use Soyuz as well, right? Like, this would be as dumb as NASA just building another space station and just putting it up there, right? And operating that and the ISS. That's why NASA's going for commercial low Earth orbit destinations, I suppose. And see, Kem, what I'm wondering is if I'm wondering if the Russian orbital space station, right, I'm wondering if it's a response to the Commercial Low Earth Orbit Development Program. Basically, the Russians see that NASA is going to make pay people to make a bunch of low Earth orbit commercial destinations, and they said, oh crap, the ISS is going to go down the tubes, so we probably are going to want to compete in that market, right? Like, they would probably push their own rules where it's going to be, even if it's going to be international. I mean, Kem, like let's not kid ourselves here. Dimitri said he wants a bigger piece of the pie. Like he wants to be a mutual partner. I understand that. That makes sense, you know. Maybe they want to play with China and not the United States. China doesn't want the Russians part of their space station, Signer. They said they want to do it themselves. The MOU between Russia and China is for going back to the moon. It's not for space stations. Because the Russians said, hey, put your space station at an inclination where we can get to it so we can attach modules to it. And China said, hey, no. True story. He got rejected, which is kind of messed up, man. Like, well, you know, they're like, oh, we're going to work with you with going to the moon. China's like, all right, cool. That's fine, man. We're going to build a space station in the meantime. Oh, cool. Can we go? No. No. What? I was literally just about to ask. Yeah. I mean, I don't know, man. Like, even NASA with like the Axiom station, they're gonna attach it to the ISS. It'd be cool if the ROSS could attach to the ISS, but once again, it's the inclinations that's a big deal. I think that's the driving factor. They asked too late. That sucks. Don't the Chinese use a different docking port too? I don't think they use APAS. They use something like kind of similar to IDSS, but also not IDSS. I think it's their own design it's their own design based off of APAS or IDSS. I forget. It's like you have everything ready and someone asks you to change something important. Yeah, China was like, no. Yeah, that makes sense. That makes sense. That and China can only launch on certain corridors. Even when Chang, there's their coastal launch site. A, it's over a main shipping lane, which it's over a major international shipping lane. And then B, they really can't go very far in every direction because they ain't launching over Japan, that's for sure. That would end very poorly. And they ain't launching over the Philippines either. That would also end very poorly. There's like a very narrow corridor. It's kind of like Boca Chica. Boca Chica is a very narrow corridor. SpaceX basically needs to launch between Florida and Cuba. Even that far down range. It just would be cool to see the ISS like 2 times the size of it is though, Kem. How cool would that actually be? That'd be sick. Anyway, so we're gonna have another special guest here up on the stream here now. Dual kill station or reality? That'd be kind of cool. Alright, so I'm gonna go in here like this.
Do you have any pretzel nugget requests?
No. No, I'm not hungry, baby. I'm alright.
I'm not asking if you're hungry. I'm asking if you would like any pretzels.
No, I'm all set, thank you.
Alright, well when they get here there will be regular pretzels and pretzel dogs and cinnamon pretzels.
Get me pretzel dogs, that's fine.
I already did, you're done.
I guess I'm screwed then. Yes, NASA man. That's why. She's like, I've only had one. I'm like, oh no. Oh no. Is the guest the DoorDash guy? No. NASA Man main Discord, dude. So, we talked to NASA Man a little while back, who had the privilege of flying on this after a short while after we talked to him. The privilege of flying on this thing. Pretend we have a flight incident, lock the door? Nah, I'm okay. This thing flew on this sucker right here, the 0G plane. 0G is for testing, for basically giving people the opportunity to experience a microgravity environment similar to what you'd find in space, and they do that by flying parabolic arches. And speaking of that, we have the man himself. Now, this is Sawyer, so the NASA man here, who had the privilege of flying on the 0G 727 a little while back, and I said before you flew, the last time we talked, that you're going to need to get us some pictures, so if you will.
Yes, you should still have that link in your DMs.
Nah, give me 1 second. You're coming in a little bit on the loud side there. I just got to fix that.
Is this any better?
I mean, just a little bit.
ASMR. There we go. No, that's my normal voice. Hey, you sound a lot better.
Yeah.
I mean, you still kind of sound like garbage, but that just made the Boston accent, so.
Yeah, well, New York sucks.
What you talking about?
I don't know. Anyway. All right.
Sorry, guys. EJ and I go back a while, so we kind of rag on each other.
No, we don't. That's wrong. You suck.
Well, you suck more.
Ow. Ow! Alright, let me go.
Hopefully the volume's better for everyone.
Yeah, no, I equalized it out. We should be good. Okay.
Awesome.
Alright, let's get these pictures here. What do we got? My.
So for those who don't know, while you're loading up the pictures, I took part in something called Mission Astro Access. So basically, it was 12 ambassadors. All of us have different disabilities. There are people who are vision impaired or blind, there are people who are hearing impaired or deaf, and there are people with mobility issues. So 12 of us, all of us with different types of disabilities, and they brought us all together for a 0G flight. Hey, that's all of us. Sorry, I'm responding with the stream delay, so it may be a double delay. But,
it's all good.
So yeah, that's all 12 of us outside of the 0G plane the day of flight. So again, there's people who use wheelchairs, there are people with prosthetics, there are people you see with canes. I mean, all of us. And that's the amazing thing, is that each of us all had different disabilities within our groups as well. So again, even though there's, 4 of us in a wheelchair, they're all different types of disabilities too.
Cool. All right, so you guys did some flying here, from what I understand. Let's see if we can get these.
And there
pictures.
is everything from the weekend. So that includes visits to Relativity Space, Virgin Orbit, SpaceX, and then obviously the flight itself.
All right, let's see what we got here. Let's take a look. So these are the pictures of your travels here.
Yes. Again, ITAR regulations, I can only show the front of the engines, as we were talking about earlier, but yeah.
Come on, picture. There we go.
I may or may not have lost my mind when I saw the Falcon booster there.
Yeah, it's
and
big,
literally
isn't it?
Yeah, and yet for me, the surprising thing was how small the engines were in comparison to the size of the booster and the landing legs. That's just my thought, but yeah.
Yeah, and one of those things can hold that thing up, because it only lands on one. It's pretty crazy.
Yeah, and again, the carbon fiber, they literally let us, knock on it, feel it, and everything. It's
That's cool.
Really interesting. So inside the engine is... Got that?
Oh, yeah, I heard all of that. That was very descriptive and informative and stimulating.
Yes, that totally wasn't the automatic ITAR sensor that just activated.
I don't know what you're talking about. It sounded right to me. I don't know if they heard it. Yeah, there you go. That's at Hawthorne. Now, you also got to go to...
Yeah, I would just like to point out that picture before you get rid of it. That is, if you go back to it a sec, that was literally my genuine reaction to seeing the booster.
Right, the pictures are taking a second to load, but let's see.
I mean, they're big, so yeah.
Is big. Bolshoi picture. Bolshoi photo.
Yeah. So this is not a staged photo once it loads again. I will point that out now. That was literally, my dad had my phone and took a picture of me just staring at the booster. I could not kind of stop staring at it. That is me blocking the sun because it was insanely bright. But yeah, that thing, I mean, the SpaceX tour was amazing. We saw Falcon 9 segments being put together. I think it was booster 1072 that I saw being assembled, so when that comes up, I'll see it. But I mean, there was 1Ds, there was partially assembled MVACs, there was a lot of Raptors, and there's also the shell for the next crew capsule, which I think is supposed to be their final. They're gonna stick with a fleet of 4. So,
yeah, four capsules is a good. I mean, that's a pretty good number for active spacecraft. I think that's. I mean, orbiters. They did 4 of those.
And
that's good.
And of course, we were not allowed to take any pictures in there, unfortunately. But I can tell you, it was awesome.
Yeah, they make you put your cameras away. Yep. That's crazy, dude. So let's go around. You got pictures. You got pictures of you with mom and dad. That's cool. Right on. All right.
Yeah, I mean the ones of me and my parents. There's the one before flight, and then there's the one of me after flight too. So they were nice enough to take some family pictures. So all of these are ones that are approved, basically. There's a lot more, but I do want to just legally point out before we start looking at these that yes, this is an FAA regulated commercial airline, and yes, it is still required by law to wear a mask on all FAA mandated flights, but every single one of the ambassadors did have a medical exemption, so that's why we are unmasked. I just need to get the legalese out first.
Okay.
And now on to the fun stuff. So yeah, in case you guys don't know the people in this photo, off on the side there is Tim Bailey, who's with Zero G and Yuri's Night, and also helped out with Astro Access. On my left is George Whitesides, who worked for the longest time with Virgin Galactic as pretty much their #1 man. And then on the right is Will Pomerantz, who is the employee number one at Virgin Orbit. And the two of them, Will and George, were essentially my personal helpers for the entire flight.
That's cool. Bro, what size?
Yeah, not bad company to fly with.
What size shoe are you?
Oh gosh, I don't even. I rarely use my. I don't really use my shoes that much normally, but I have them on. I guess it's size 10, I think. 10, 11.
It's a big shoe. You know what they say about big shoes, right? Big smiles.
I thought we were going back to docking ports. Anyway.
Nah.
Yeah. No, the smiles, and that's the thing is, none of these smiles are staged. Every single one of these was taken totally just me and my natural element, and pretty much everyone that I talked to after the flight was like, your smile through that whole thing.
Dude, man. So guys, Sawyer's in a wheelchair. He got sucker punched when he was a kid, and
yeah, it was by a bully in middle school in the gym locker room.
This dickhead sucker punched him and knocked his legs out, which sucks. Like, screw that guy. But Sawyer hasn't walked around in a little while, to say the least. How long?
15 years.
But man, seeing you stretch out, dude, that makes me so freaking happy. I said it once, I'll say it again. That makes me really happy. That's really cool.
Yeah. If you want for a second, before we go through the rest of the zero-G photos and I talk about the insane rest of the experience, there is another subfolder in there.
Oh, subfolders.
At the very top. So, basically, there was 15 total parabolas. The first one was Martian, and then the second and third were lunar gravity. So these were the actual ones from the lunar ones. This is my actual reaction to it. So basically, what happened was we hit 16G, and so I pushed off of the floor, and I kind of acted like a pendulum. So my body went up, but my legs kind of stayed in place. So all of a sudden, it took me a second, and I realized, oh my gosh, I'm upright. So thankfully, again, the Will and George were there. So I grabbed onto their shoulders, and at one point was literally standing upright, and I actually shouted, oh my god, I'm standing.
That's awesome, dude. God, that makes me
If you flick through, I think there's one in there where you can actually kind of see my feet almost on the ground.
Let's see.
Yeah, these were all of the ones where it was my, oh my god, I'm standing. And I remember after the first parabola of lunar, we came back down, and they're like, so what do you want to do for the second one? I'm like, I want to do that again.
Yeah, dude. Yeah,
so,
there you go.
Like, did it really happen? Was that real? So yeah, the second lunar parabola we did the same. Yeah, that's the pure raw joy of me coming back down. Like my legs actually bending down after standing. It was, yeah. Everyone talks about the zero-G parabolas, but the lunar ones were special.
Okay. Now, I'm kind of asking because I know people are curious and stuff. Like, so if I'm crossing the line, dude, I'm not giving you crap. If I'm crossing the line, you think some of these questions are bull crap.
I'll tell you.
Yeah, I know, but just in case, like, and that goes for everybody in chat too. Like, guys, I've known Soy for a long time. If we're giving each other crap, that means everything is cool. So, all right, I have questions. So, like obviously, I mean, you can't use your legs, but there's bones there and stuff, right? Like, obviously, right? So in the lunar test, could you actually like just stand up with your legs just kind of supporting the rest of your body upright in lunar gravity? Like obviously you can't like walk around, right? But could you actually stand up like and just kind of sit there and be like, "Yep, I'm standing with my own legs right now"? Is that what happened? Like,
kind of. I mean, again, I had to, when I went upright, it took me a second. So basically there was a second or two where it was solely just me on my own, but I did need the light support on their shoulders. It wasn't much, but light support was enough.
That's what I'm wondering. Like, because like, so like, say sometime in the future, man, like if you have like you could have like an EVMU or an A7L spacesuit with like a little solar panel on the back, and you could have like just electromechanical stuff like Forrest Gump style. You'd walk around no problem. Like that's
that's one of the talks that we were discussing for possible future things. Is there's a guy at MIT. We worked with the MIT Media Lab on some of this, and he works with exoskeletons. So the thought is like, what about putting an exoskeleton in a suit?
Because on Earth the power draw would be insane, and that's why we don't do it, because Earth's gravity is a pain in the butt comparatively to like everywhere else, right? So like on the moon, that's a very real concept, and that's the reason why I asked the question. Like that's super real. Can you stand you stand up just fine? Like that's cool, man. That's really neat.
To give you the best perspective, look for the one that's 446 in there. If you sort, that one is the third one, I believe. Yeah.
I see. What about an exosuit in 0G? Well, Brem, that's what I'm saying. But at least in the gravity, like in 0G, like, okay, so sorry, you were talking about this. Like, what are you going to do with your legs? Are your legs just going to ragdoll around like Gary's mod or something? I can see they have harnesses holding them together, right?
Yeah. So this is kind of your answer of standing on my own. So they were kind of there just to assist, but you see I'm not holding onto their shoulders. My feet are kind of on the ground. So
hey,
that's me actually standing independently right there.
That's so cool, man. That makes me so happy.
Again, the guys are there to kind of just help, and I remember talking with them after the whole flight, and it was like, I remember just like how I was smiling so much during the flight, and Will was like, I think may have been smiling as much as you. He was just so happy to see me standing, because I've known Will going back years when he was on Space Vidcast, if any of the old timers remember that, from like the end of Shuttle days.
Wasn't Space Vidcast, that's TMRO, right? That was like pre-TMRO.
It is now.
Yeah.
Correct.
Yeah, that's old school.
That's what I mean. Back when they were tweet ups, we met at one of those, that kind of thing. So
that's cool.
That made the connection that much greater. And obviously over those days, I also really bonded with George Whitesides, and we connected over certain things, and it really I think that made the experience even better for all of us, that we all kind of got to experience me standing for the first time in a decade and a half together.
That's cool, man. That's freaking wild stuff, dude.
Man,
dude, that's not like I'm just turning over how easy it could be for you to be totally mobile on the moon. That's so doable, and hopefully, that's why they're doing this. They're doing this stuff, guys. That's not that big of a problem to solve, but the benefits are, I'd say, pretty good. That's really cool, man. That's cool.
So we can go back to the 0G stuff. That was the first 3 parabolas. And, I mean, the rest of it was... The beginning was quite, getting my bearings, getting used to it, realizing, oh my gosh, I'm kind of floating up. So I did hold on to the rope a lot just to kind of brace myself. Because, I mean, the big thing is because you see a lot of people kind of like Superman with their arms out.
Mm-hmm.
For me, my big thing is I didn't really know what my legs were going to do. I didn't know if they were going to float forward or backward or stay outright. So a lot of my time was kind of watching my legs, and I was worried that if I let go, that my legs might kind of go all over the place.
It's like
forgetting again that I have two people watching me the whole time. But
yeah, but I mean, your situational awareness doesn't go away just because that the freaking wires are unplugged. You know what I mean? Like that doesn't go away.
Yeah. So one thing while we have this picture up, you can kind of see it right below my knees. See that little silver line there? That is a Velcro strap across my leg. So that is what's keeping me from doing the splits. That's keeping me from doing and allowing me to have grandchildren. So. I know it's not after hours, but I'm sorry.
No. I mean. That
any guy in the crowd would understand not wanting to do a split.
Yeah, no, I mean, that don't change. That's what I mean. Just because the wires are unplugged, that doesn't change. Standard rules apply here.
Yeah. So yeah, again, like you're saying, we kind of really didn't know where they were going to go. So of course, the first thing is kind of just floating up, and I know someone in chat mentioned this, that you'd think it would go to a fetal position naturally, but again, there's no gravity to put it into any specific position, so they just kind of float up, and Newton's laws of gravity. No force acted upon it, it's not really going to go anywhere.
Yeah. That's wild.
But there's an interesting one. If you go through, you can see me kind of bent upward.
What's the number? 507?
The one to the right that you have your mouse on.
This one. All right, let's see what we got.
So one of the things that we were trying to test was leg position. So could I get my legs into sort of a kneeling position, which is kind of more...
Yes, Jackie. Go ahead.
Which is kind of more natural for me getting around a spacecraft or somewhere and doing work, having basically leg control. So you can kind of see that was what we were doing on this one. So I had a little piece of fabric on my suit right above my leg. Very tiny, literally 1 or 2 fingers fits underneath it.
Okay.
And so, yeah, correct, no feeling really with it, just, kind of tingling from nerves. But anyway, so I lifted my legs up, and sure enough, they went into a bending position, and it was great. So I'm watching my legs this whole time, so I'm looking to see what they do, the effort, and in 0G it was super easy. The next thing I know, I look up, and you can kind of see my head starting to look up and realize, holy crap, I'm almost on the ceiling.
Yeah.
Face first into it.
Yeah, I mean, it's freaking... Yeah. Looks like you're deep in thought there for a second. You're like, wait. Oh, yeah, this is what I'm doing. That's cool, man.
It's not so much that. It's when you do it, you kind of expect, okay, if I pull my knees in like that, the momentum is going to start spinning me backwards. That's my thought.
Yeah.
It turns out it didn't do that. When I pulled my legs in, it actually gave me upward momentum and propelled me face first into the ceiling.
Well,
I will say the ceiling and I became very good friends on this flight.
Yeah, that's not a bad thing.
But so the first two... Thankfully it was padded, but the first 2 times I did it, it was like, oh my gosh, I'm on the ceiling, holy crap. And then a few seconds later it was, feet down coming out, which is what they say when you're about to go back to gravity. So it's the scramble to try and get back down. But I did it a 3rd time later on in the flight. Because, on my wrist I had a plan that we were going to follow. And, as we were going, it kind of evolved, especially as I learned what to do in 0 gravity.
Yep.
And the 3rd time that I tried it, I used the strap that was holding my legs together and pulled up with that instead and had one hand on the ceiling. And when I did that, I could let go and actually float in place with my knees bent. So it worked eventually once I knew to cancel out my momentum.
Yeah, there you go, dude. Yeah, see, that's cool, man. Yeah, you can just kind of chill there. That's so legit, dude.
Yeah, I think the smile kind of says it all there. But
that's what I said, dude. Big feet, big smile, man. Obviously, duh.
Yeah, and so for the gravity portions, you can kind of see it behind your head. So there was a wedge on the wall and then a towel that went underneath my knees. So there's your proof that that's actually floating. It's the towel's kind of floating around. But so that was under my knees just for the high G portions, and then there was the wedge. And in some of the photos where you see the floor, you can kind of see that there's a piece of tape on the ground.
Yeah, we see it.
Different from that, actually.
Okay.
Let me see. Yeah, I mean, again, it's hard to.
It's behind the guy's hand, right? It's like right here. That's what you're talking about, or are we talking about this piece of tape on the right?
None of those. No, it's cut off in this photo, actually.
Okay. Yep. So, it's behind you.
No, here. Let me look through the numbers really quick, and I'll get you which. Yeah, I mean, there's so many good ones, but.
So, while you're looking for it, just refresh everybody. What was this for?
So this was to prove that space is for everyone. That no matter the disability, everyone can fly into space. I mean, the main things that we were proving with me was moving point to point, positioning my body, and basically trying to get back to a spacecraft seat. Although it's hard because the parabolas are approximately 30 seconds. Sometimes they're a little less, sometimes they're a little more, depending on the air conditions and the turbulence and things like that. If you look at 503, I can point it out to you.
503, let's see, where are we at here? .503, coming at you.
So if you look...
I had it open.
Yeah. So to the left of my shoe, you see that extra little piece of tape on the floor?
Yeah, I got you.
In front of the wedge. So that tiny little piece of tape was a target. So that's literally what we aimed for at the end of every parabola, that my hips would line up exactly with that, and then I would lean against the foam wedge, which is basically like the equivalent of leaning back on a seat.
Yep. Yeah, okay. I got you.
So we were 14 for 15 on those. Only one did I end up where my neck was off the wedge and my head was against the wall, which was a little uncomfortable, but...
Yeah. Cool.
Do you feel your stomach like in an elevator? At first, kind of. Basically, trying to describe zero-G is weird. The best way to describe it is when you get to the top of a roller coaster right before you drop, but then you never drop. You kind of just stay there. You know, like that feeling where you're just about to float out of your seat right before the wham of going down? It's kind of like that. And then the actual parabolas itself, the way that I try and describe it is kind of like if you're on a memory foam mattress, you're kind of sunk into it, and then very slowly someone pulls the mattress out from underneath you. So it's very gradual, and then you're kind of just there, and then at the end of it, someone just puts the mattress right back underneath you slowly. I don't know if that describes it in any way, shape, or form, but it's...
Sounds about
right.
Or
like on the top of a swing, yeah. That feeling, but constantly. And... it was kind of really hard to tell exactly that I was in zero gravity for some of it.
Yep. Go ahead.
Good. Yeah.
Just had a subway pop through.
I saw.
Sweet.
Yep. 3 months. Nice. Anyway, so I had with me a ping pong ball actually, and I had it in my pocket. It was from my grandparents. We did this stupid thing years ago. And I was literally a kid. They shot out a whole bunch of ping pong balls for New Year's. My grandparents have been collecting them, and so they sent me one of them for this flight, and it said, "Do balls float in zero gravity?" And so I put it in my pocket, and then during one of the parabolas, I told them I want to take it out. So we don't have the video yet, but I did it right in front of the video cameras, and so they gave me the trick. So I held out my hand, moved my fingers away from it, and slowly pulled my hand back away. Unfortunately, there's no photos of it.
Yeah, I'm just finding another photo.
Yeah,
with a
and then the ping pong ball just floated there and stayed there. And it's such a weird feeling. You expect it to drop or hit the ceiling, and it literally just stays there.
Yeah, it's wild.
And so I poked it with one of my fingers gently and just slowly watched it float across the plane until I caught it back in my hand. I literally held my hand out and it went right into it.
That's mind frick right there, dude.
That was the one that really made me feel I was in zero G. The one that was the true mind frick was I wanted to do the flips. I mean, everyone goes upside down. I wanted to do it. So I I told the guys, I'm like, look, I want to do a flip. So we picked a parabola, and I literally, went upright from the floating, and they turned me like the hands of a clock sideways. And the next thing I know, I'm upside down, and I'm looking around going, wow, there's a lot of people on the ceiling for this parabola. And then it took me a second to go, no, you're the one whose head is on the floor.
Yep.
So my hair was touching the floor, my feet was towards the ceiling, and it's, it's bizarre because you don't get that blood rush to your head. So it's not like I could have that sensation of, oh my god, I'm upside down. The blood doesn't rush to your head in 0G. So it just kind of felt, oh, everyone's the wrong way round.
Huh.
The other interesting thing kind of going along with that is I actually pain in any of the zero gravity portions.
You cut out for a second there. Repeat that one more time.
Pain for any of the zero gravity portions.
No pain, nothing.
I mean, like, I had wrist pain from wheeling all around California. I have neck pain and back pain, and all of a sudden I was floating, and I just noticed, I'm like, wait a minute. My body actually feels good. I don't feel any pain.
Everything gets all stretched out, man. You take load off the joints, dude.
Yeah, it was bizarre. And to answer Moto Kid's question, the 2Gs wasn't actually bad. I expected it to be a lot worse. It was kind of nice, actually, just having the force push against you. They tell you, though, look at one point on the ceiling. Don't look anywhere else. So that's what I did. But there were a few where I tried to lift up my arms, and it definitely felt like someone was pushing against it, going, nope, you're not lifting your arms here.
Yeah, the closest thing I've experienced to that is Mission Space at Disney World. It's like 3 to 5 Gs sustained because it's a centrifuge. Yeah, you try to lift your arm up, it just goes, nope, 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 nope.
And then when I'm in zero gravity, I go to lift my arm up, and it's easy. So it's not like I'm, pushing up against air. So it kind of just goes. It's like, all right, my arms are just kind of wee. Almost like it has no bones in it, even though they obviously still do and still work.
So, was the no pain possibly just due to a huge adrenaline rush? That's a good question, Glenn.
No, because I could tell you I was in pain before and after. Definitely. It's just so, yeah, and amazingly, my heart rate was lower than it's ever been. There was no like, oh my gosh, heart pounding. Oh my god, how am I going to do? It was great, and I would like to point out that I still have my barf bag with me because it is unused.
So you John Young'd it. I see how it is. Very good.
So freaking Lily. Who else should I model after, right?
Yeah.
I survived the vomit comet without the vomit. But the coolest thing also was, at one point of the parabolas, I kind of just looked... I literally got advice from someone that was, take one parabola and just take a mental snapshot.
Yep.
And so I did that. So one of the parabolas, I literally just floated there, turned to my right, and just watched everyone else. And I just remember seeing everyone in all different kinds of orientations, upside down, right side up, sideways. And it was amazing because every single one of us is bound by a disability on Earth. And here, there was no gravity holding us down. There was literally nothing holding us down or holding us back, figuratively and literally. Everyone was floating freely, exactly the same. Everyone who was struggled exactly the same. So you had 12 people with 12 completely different disabilities who have to deal with these struggles on Earth, and all of us had the same shared struggles in a weightless environment that anybody, ability or not, would go through. And it just kind of put it into perspective that this really is for everyone. Once you're in zero gravity, there's literally nothing holding you down or back.
So you're telling me your Dragon 2 doesn't need a handicap parking spot on the ISS?
Hell no. Keep your placard.
My guy. Yeah. Awesome.
But honestly,
nice.
It's just so nice to not be bad. The word was freedom. Absolutely freedom during that. And it's the same for, everybody. All of us kind of just... I'm getting reverb all this. Oh, that's my cat unmuted. Give me a sec. It was just... Freedom is really the word for it. All of us kind of just did our thing. Like you could see in the photo even there, just one of the guys floating behind me who day-to-day life is in a chair, just like me. Jeez. So it was...
Oh, that's good, man. Like
it's
I
an
said.
unreal... it's an unreal sensation. It's an unreal feeling. And yeah, again, the fact that the biggest thing was that we wanted to prove that it literally doesn't take many modifications to make a spacecraft accessible. So I've got a handrail. Boom. Done. I had a Velcro strap between my legs. Boom. Done. What else did I need? Someone to help get me to and from the floating area. That was it. So in the actual floating parts, I mean, again, they did help me get down back to the ground. And on a second flight, that's something I would want to test is, okay, you spend so much time floating up and getting around that learning how to move in 0G that you have to rush back to the ground. You have like 2-3 seconds before gravity hits. I would want to rush up now that I know how to maneuver in 0 gravity to the top of the ceiling and use those 20 seconds to say, okay, can I get myself back down into a seat? Because you're going to have to get into a seat, strap into a 5-point harness, and re-enter.
Yep.
So that's something I would next is, can I just maneuver down on my own? And it would probably only take just a few straps.
Oh, excuse me. I was going to say, you could go over to your chair and then come back. That's not, that ain't an issue. I don't think that's too, like, if you're like flying on Dragon or something, like that wouldn't be too big of a deal. I mean,
not at all.
You said you needed handrails and Velcro. That's already there. They already have all of that on the ISS, like right now. Like you could go there right now and it wouldn't be an issue.
Exactly. I was talking with astronaut Katie Cole, and she calls it MVP. So not only is that strap between my legs the MVP because it kept me from doing the splits, but it's also minimal viable product. So what's the least that you need to make it work? And you see, it's literally a foam pillow that we bought from Kohl's to represent a spacecraft seat, some duct tape, and Velcro.
Yeah. Dude, Rocket Guy said it in chat a second ago. Duct tape's proven its worth again.
Oh, 100%.
Yeah. No, dude, that's not a stretch at all, man. Okay, you were talking about a second flight. So where do we go from here? Are you going to fly again or what?
I would love to. I mean, right now the goal is obviously to bring awareness of what we did and to show it to space companies. And that's the amazing thing is on board that plane, there was somebody from every single flyer. So basically there was a person from SpaceX on that plane. There was a person from Virgin. There was a person from Blue Origin. They were all on board that plane. They are not there representing their companies specifically.
Yeah.
But people from all three companies who work there on the side, or, who work there for their main job and help with this on the side, were represented. So there is a way to bring it back to these companies and say, look, we did this. It didn't take much to make it happen, so let's do it.
Yeah, I mean, like you said that, I'll just pick this one out right now. You said that somebody from SpaceX was there. Well, I would imagine if they're going to do point to point, that they're going to need to figure this stuff out. If everyone's going to fly on like a starship that goes from like Beijing to Los Angeles, right? Like, SpaceX.
Oh, absolutely.
SpaceX is going to be like, oh, you're in a wheelchair, you can't fly on this rocket to there. I'm pretty sure that wouldn't end well. So yeah, that makes sense that they would be there trying to figure this stuff out.
Yeah, so again, the goal now is to do a second flight. Not sure how many ambassadors that would be. And again, we've also still been working with MIT Media Labs on coming up with some of the solutions we tried. So obviously some things worked, some things didn't for other people, especially depending on, the different disabilities for hearing or vision impairments. The coolest, though, is some of the people with prosthetics. There's literally pictures of them floating with their leg in front of them, like their prosthetic leg separated from them, floating. It's
nice.
It's freaking awesome. It was kind of cool to see that, especially when you get to know these people over the course of 5 days. But yeah, there are still, there is still a thing on the website for donations for future flights, and if you don't want to do that directly, they have some awesome T-shirts that we all got too that were designed by disabled artists.
Oh.
All about making space accessible.
Cool. That's cool, man. That's good stuff.
I'll drop those.
Yeah,
I mean, they're cool shirts anyway, and I don't make any money off this. All half it goes to the artist to help Mission Astro Access.
So Brimo actually has an interesting question here. What kind of other experiences do people have? I'm really curious what happens to someone. I think I saw somebody that was blind in the original 12 shot. Like, what about people who were blind or deaf? Like, was there anybody like that? And how did they fare, if you don't mind me asking?
Not at all. So there was 6 people with mobility problems. There were 2 deaf flyers and 4 who were either low vision or blind. And so from the blind side, when I was talking to them, they basically said that they did end up bumping into each other quite a bit.
Yeah.
But again, they had that kind of surreal, weightless feeling, and some of them said that during most parabolas they could still kind of sense, just based on what was going on, what was up, what was down, and which direction they were facing. Part of it is also the day before we did a test run, and we literally went through the plane, so the people who were vision impaired went through and did a feel through of the plane to kind of get a mental map of where everything was. But a lot of them said they used kind of the handrails as guidance of where they were in relation to ceiling or floor.
Yeah.
So, there were some issues. And again, the other thing is making sure they know which way is down as it comes back to when we come out of 0G and back into regular gravity. Then there was the deaf flyers, who I was talking with one of them, and he was saying that he tried to sign to the interpreter who was flying with us, and he was upside down and the interpreter was right side up. And he literally signed to him, "Oh my gosh, we're talking upside down." And they were able to understand each other. That's the cool thing. So they were able to understand sign language while upside down and right side up. The only issue that they experienced is that all of the commands to re-enter are verbal. So basically we tried haptic feedback on it, so things that would vibrate to let them know. The problem is, by the time the message gets from the cockpit to the person on headset, to the person who calls, feet down coming out, to then the person who pressed the button on the app, to then buzz the haptic feedback device, by that point you're already on the ground. So things like that will need to be worked out. But, I mean, it was cool that they were literally signing with each other upside down.
Huh. Dude, I don't think I can even read upside down, much less in microgravity, right? Like,
yeah. It's crazy. And again, for the people who said it feels like you get vertigo, it doesn't, because you don't have the blood rush to your head, so you don't get that vertigo feeling. And even the people who are vision impaired, some of them can only see light, while others can see, a little bit of detail, and others can see nothing at all. So, some people had more awareness of where they were than others, but all of them basically said they had the same kind of floating feeling. They had that same kind of feeling of basically a lot of bumping into each other and landing on top of each other sometimes back in gravity. But overall, they proved that they could get back to a spot and do it too.
Yeah.
Yeah, if you need, I can send you some pictures of the other flyers flying as well too.
I got the picture of the group. Should be good to go.
Yeah, because, I mean, there's some of them upside down and all that. All of us were all over the place there. And yeah, it's flying in a 727 is unique too. Turns out it's a modified cargo plane.
It has the ramp then going into the cargo bay, right?
That thing has some freaking zip to it. Holy crap.
Man, there's a small
on
plane.
takeoff, that thing... They punched that thing too, the pilots. I mean, they did a great job of flying it. And I actually I can send to you if you want to kind of scroll through it, the flight aware of our flight. So that was...
It's gonna go up.
Yeah.
Up and down.
Oh yeah, it's crazy. They literally, you can see the up down. Here, let me see if I can get that to you, because it's such a cool thing.
Mm-hmm.
If you have any questions while I'm looking for it, or if chat has any questions.
I think I'll explain what the heck this thing does. So guys, actually that's a picture with you folks. I don't want to use that. I'll find the 12 picture again. So that's 727 behind him. Basically what this thing is designed to do, I mean, it's 727, it's a passenger liner, but this is a cargo one because it has the big cargo door in it, right? What this thing is designed to do is designed to fly parabolic arcs. So they get this plane up to altitude, and then they just do this. It goes up, and then it goes down. And then it goes up, and then it goes down. And then it goes up, and then it goes down. The idea is that when you get to the apex of these arcs that it's flying, you experience microgravity. Very, very similar to what you'd get when, you get launched into space. Like when a spacecraft has main engine cutoff, they get into space, you have that kind of weightlessness thing going on here. That's what the plane does. The 727 mimics that by doing this. It just goes up and down and up and down and up and down and up and down.
Yeah, pretty much.
Yep.
I'm trying to get this downloaded and over to you. But, yeah, I mean, there's also a group photo there with the entire group, because there's a lot of support staff, too. There were also people on that plane. Again, there was interpreters. There were, people with MIT that were, using it as research as well. So it was a very, diverse, great group of people.
Yeah, that's...
And I am proud to say now that I'm also officially zero gravity certified.
Well, that's pretty neat. The flight path, you can zoom out on the map for altitude deviations.
I don't even know if we're friends on Facebook, because I have it on Facebook Messenger from my mom. I'm trying to figure this out here, but it's the craziest thing.
Oh, yeah,
unless
there they are. We can see them.
Yep.
Yeah, see the color changes? Up and down and up and down and up and down and up and down and up and down. What type of deviation are we talking here? It looks like you're going 20 to 30,000 feet right there. You're going 10,000 foot arcs right there.
If you pull that one up on FlightAware, I believe it has the exact altitude up and down. It was kind of ridiculous.
You back up 75 months.
Here, let me get it for you.
Yeah.
I think I can do it, because that is the correct call letters and everything for it.
Yeah, chat found it, dude. I'm telling you, chat's better than a Google search, man.
Yeah, you're not kidding. Yeah, this was our exact flight here. So I will post it in chat so everyone else can see it as well, and that you can check it out too. But I mean, at the bottom, it shows you the up and down and up and down. And yeah, ignoring the pattern. But basically, we went forward and backward and then looped a few times so that we could do the 15 parabolas. So that was our actual flight on the 17th of October. There you go.
How do you file this flight plan? Like, what do you file? Like, what do you do? How do you file that?
It's block altitude.
Yeah, I guess that's probably why they went out over the ocean when they did it. Like, they went out.
Yeah.
Heck, man, you were up past San Francisco. Probably found a nice empty spot and just...
I mean, sometimes they send us right off the coast, but yeah, this time they did send us all the way up past San Fran. But you can see, I believe the green line is the altitude and the yellow line is the speed on that chart. And if you hit replay, you can actually see it go wee wee. And you'll notice that it's not consistent, so we had gaps. So there were gaps in it where we would do 3 at a time and then take a 1G break, basically. So yeah, there's your the ups and downs.
Oh, man. Yeah.
So yeah, it's like 30, 20, 30, 20, and then the speeds, 600, 300. Or even,
look at
into the 200.
Yeah.
So yeah, you see every time I do the parabola, the basically 5,000 foot altitude change. In some instances, it was 7,000 or 8,000.
Yeah, man, this thing's really going up and down. Here,
and it's the speeds. It goes 600 down to 300.
Yeah, it's crazy.
Yeah, it's absolutely insane to do.
That's awesome, man. Well, I'm happy you did it. That's really cool. I can't say this enough, man. It made me really happy to see you standing up. That's really cool. Hopefully we get to see that more in the future.
I hope so too. I mean, the whole thing that this really proved is space is for everyone. The fact that all of us with all different disabilities were able to stand, float, move around, and do everything that a normal astronaut can do. So, I mean, right now, I believe the only one that does not have a policy that says we won't fly disabled astronauts without wording it that way is Virgin Galactic. Blue Origin says that they have certain health requirements that may exclude people from flying on their craft. SpaceX didn't comment when asked, and NASA outright said no.
Yep. I mean, with NASA for like science missions, that I kind of understand that. Like, if you're going out to the moon to do research, right? Like, I get that, but that doesn't mean that somebody couldn't like live on the moon, like as a retirement. You know what I mean? Like, that's totally doable.
Oh yeah, absolutely.
Like, I get the reason why they said no. It's not just because they're oh no, we'll just screw you. It's too much work. No, that with the types of requirements that they do, they need They need people that are able-bodied. I mean, it's hard for those folks to do it, you know? Like, I get that, but, you know, for, like, suborbital flights, like, that's cool that Blue Origin was like, yeah, sure. Well, you know, as long as your ticker works, right? Like...
Certainly, yeah, Virgin was the one who outright said, we have no restrictions on anybody.
Yeah, there you go.
So, yeah, again, that's not a dig on any of these companies or any of these agencies.
They did good work, man. Anybody that, I always say it on stream, dude, anybody that's ballsy enough to say, I'm going to make anything fly into space, even if it is for a second, like, you know, has my respect.
Yeah, and again, this group was absolutely amazing that helped make this happen, and in a year they just said, all right, we're going to do it. And I mean, the thing costs about $250,000 all in to help fly us, but we proved so much in that one flight, all 12 of us, that it's amazing, and I can't wait to see where we go in the future. And I may pop in one more time once the video drops, just for 20 minutes, just to, of
course,
have a little fun.
Yeah, absolutely. Well,
because there's also a documentary in the works, by the way, folks, so that may be coming to a Netflix or a theater near you in the next year or so.
Sweet, man. That's really cool. Well, hey, good talking to you. Thank you for sharing this with us. That's pretty awesome.
Yeah, absolutely. If anyone has any other questions, you can shoot me a message on Twitch or on Twitter or Instagram. I'm the NASA Man on all of those. And check out Mission Astro Access for all the details on the flight and all of the different experiments and everything we did.
Awesome, dude. Well, hey, thanks for coming on. I appreciate it. That's real, dude. I don't really have much to say. Like, that's so cool, dude. Standing up, man. That's
that means a lot, EJ.
I don't mean to be like just double rainbow, but I don't think people realize how cool that actually is. That's sick.
Considering how long you and I have known each other, yes.
Yeah, we've been friends for a long time.
Yeah.
I think NASA need to do some research flights with disabled people. Well, W, that's what this was about. That's what this whole thing is about. But it's privately funded, so it'll probably get done faster. Sorry. Sorry.
From first conception to actually flying was about a year. So, yeah, it got done relatively quick.
You mean in space? I'm sure there's someone working on that somewhere, W.
Yeah, I mean, the goal with this group is to eventually get at least one of us into space on either a suborbital or orbital flight. And I volunteer as tribute.
Fair. If you need somebody to, help you out just in case, I mean, you clearly don't need help in microgravity. It's clearly cool. But if if you needed someone to help you out when you go to fly into space, I mean, Yusaku Maezawa's flying into space in another couple of months. He has his assistant with him. I'm just saying.
Fair enough. I will put you in consideration. Top of the list right now.
Wait, that worked?
Absolutely.
Oh.
Dude, who else would I pick that knows as much about space and is as much of a space geek about it, and also actually has the physical capacity to help me?
All right.
You fit the bill. You got the job.
Okay, cool, sweet. All right.
EJ and the NASA Man joint broadcast from space coming soon.
Yes, we should. Yep. I like this plan. I'm happy to be a part of it.
Yeah, Scott Manley, no. I still pick EJ. No offense to Scott, he's awesome, but I still pick EJ.
That's right, Scott. That's right. Be there. No. All right, man. Hey, good talking to you, my brother. Thank you for sharing this with us. I do appreciate it.
Absolutely. Thank you for letting me share it, and thank you again, everyone, for listening. And I hope you enjoyed the photos and the stories and what Mission Astro Access is all about.
Cool. All right, man. Good talking to you. I'll see you later.
Yeah, I'll be around in chat probably randomly throughout the night.
All right, bro. Later.
Bye.
So that was the NASA man here who flew on a microgravity flight for Astro Access to show that folks with disabilities can fly can operate in microgravity environments. That's really cool. That's really freaking cool, man. That makes me happy. Sawyer just a second ago said it best. Like, all you need is a handrail and some duct tape and some Velcro. I'm pretty sure they have all three of those things in space already. You need those to move around. Well, duct tape to not move around, but you get the idea. And Velcro too to not move around. But the handrails, though. The pretzel dogs are here. Oh boy. Sweet. Okay, so let's continue up here with the space news. I was a professional assistance person for 6 years. Happy to volunteer and/or pay my way on anytime. There you go, Bon. Cool. All right, so check this out. Check this out. Everybody knows that the Franken crane, as it's been called, that's down at Boca Chica. We're gonna do some Starship stuff right now. The Franken crane the boom was lowered for the last time. That Franken crane, so the Liebherr, what is it, an 11350 with the power boom, the one that lifted Starship for the orbital stack? Like a number of months ago, the boom was lowered and the trucks are staged for it to be disassembled. And everybody was wondering, well, how are they going to stack Starship now? Surely not the chopsticks. Well, I think you have your answer here. These pictures are coming from NASA spaceflight. Mary took these pictures over at NSF. We'll probably see something about this in the video here that I have teed up, but let's see what we got. The handrails should also not move around, but the handrails make you move around. That's what I'm getting at. So, SpaceX crane. SpaceX crane. Oh. Hello. So, this is the bottom parts of the crane here. This is a brand new Liebherr 11,000, Thomas, right? Yeah, you already said it. Okay, cool. It's not a Franken crane. It's not an 11,350. It's just an 11,000. Just an 11,000, which clearly is good enough to lift Starship because it has. It's what the 11,000 is what put Chip 20 on its test stand, so it can clearly lift it. So this is the body right here. See these sleeved holes right there with the metal sleeve in it, the bearing in it? That's just a solid bearing. That actually attaches to the trucks. See, the trucks have the hooks right there. 1, 2, 3, 4, 5, 6, 7, 8. They actually hook together like a Lego Technic kit almost. And then they put the pins in, and this is the base of the crane. And then there's the pin right there. See where the reinforcement is? That's the pin. And then the white part up here, see these two loops right there? Those loops attach right here. 1, 2, 3, and 4. And that makes the base of the crane. Now, on the white piece over here, so that's the operators, that's the booth, that's the house right there. That actually pivots, and it rotates 90 degrees so it faces stage right here, so left side of your screen. This thing actually is up at the front and it rotates into position. It mounts right here. You see it has the walkways that actually fold out. These are the walkways. Now, Goalie, I don't think this thing has anything attached to it. The mast isn't there. The pulleys are, though, I think. That's the cab right there. Yeah, this is the house, yeah. 11,000 means it cost $11,000. Yeah. Sure. The full white thing is the house. There you go. Does it have that new crane smell? I bet you this smells like lubricants. Yeah, I'm just going to say lubricants and just leave it at that. What kind of lubricant? Dude, you don't need to know. If you have to ask, you have no idea. There's the jacks right there to plant the thing into the ground if it's moving something heavy. These things fold out, and it's a hydraulic jack to hold it in place. That's cool. It's brand new, dude. Look at how clean it is. Everything's nice and clean. So, Goalie, this doesn't have the mast attached to it, does it? It smells of money. This is what it smells like. Oh, all right. That's to put the tracks on. Oh, those jack things. Oh, I see. Because it's got to lift up so you can attach them. You gotta lift it up, and then the tracks have to. Wait, how the heck does that work? Magnets? Oh, wait. There's a hook right there. Does it? You have to lift it up into position. Do you roll them into position and then it lifts? It moves upright. Wait, I'm confused. How does that even work? Hang on, I gotta look at this again. How do you put this thing together? Oh, it pivots. Got it. It pivots. So the truck gets attached bottom first, right? So you lift the thing up, right? You attach it, and then you lower it, hook that in, and then it lifts the whole thing up. I get it. It pivots on this. So that if you're looking at the track like this, right? So the X would be on this side, right? You bring the pin in, right? Bring the truck in, lift it up like this, lock it in. Yeah, there you go. I see it. I see how this all works, and then it hooks in. That's cool. At least I think that's how that works. Part of the Starship launch tower has a crane on top of it, at least in the drawings and the models. Yeah, I'm not sure if they're still doing that, Jen, but we do know that there's an Appleton Marine crane that's at Starbase. Something that could, like, it looks like it should be on top of that thing. All those sections are already together. Let's take a look. Who is this? Starship Gazer. Oh, yep, there it is. Dude, look at how much this bends back when it's oh no, it's on a hill. I was gonna say, look at how much it's bending back. Did they put counterweights on it or anything? Or... The motor is in the house by the cab body, but nothing hydraulic. There you go. Yeah, it's right here, is it not? And then there's room for more of them if you need them. There's depending on the configuration of the crane. I mean, these cranes are like freaking Lego kits, dude. It's really crazy what these things can actually do. Yeah, lowboy trailer right there. Now I'm trying to figure out how the heck this thing goes together. How are you gonna get this thing on there when can you Goalie, can you push these things when they're in neutral? Like in neutral, I know it's obviously not that simple, right? Can you roll this thing around? Oh, hey, the voice is back. Yeah, I'm good. You can't put counterweights on until you at least put the heel in. Yep, the keel in. Yeah. Okay, so they can roll around. So that's what they would do, right? You'd use like a bulldozer or something to pull this into position. But even then, how do you pull that thing to line up with the slot? I don't understand that part. I know that the pin, this whole pin section, you said that those are for installing the tracks. These things probably move down, right? And that moves this thing up. But how do you get the truck to line up to it? I don't understand that part. Can this thing move by itself? Does it have like wheels on it or something? Yeah, Aiden, it's pretty cool. I gotta find a video about this. Hold on. I know there's videos of it floating around. Give me 1 second. Here, let's see. Track lift. Let me see. All right, I'll pause that video. Let me take a look. All right, let's get to the... Oh, so there's the mast, right? They're gonna, okay. Oh, yeah, that makes more sense. Crane to build the, oh no, the crane can build itself. What? The crane can build itself. Did you see that? It's self-aware, we're all gonna die. Yep, there's the jack to put the pin in. They're just straight up using the mast. You can use, so this is the crane mast right here. Whoa. Yep. Does the same thing, and then, okay, so there's some concrete to, you know, hold that in place. 15 tons. How does this thing hold itself up? Like, I understand tank treads, but how does this not break? So, okay, he's moving the mast there. Yep, okay, so see, you can install like 3 or 4 winches on this thing. See, look, look, look. It's freaking totally, even the house is totally configurable. Okay, there's the slings. Ballast handling, easy and safe. And if one lands on you, it's really safe, because you don't need to worry about going to the hospital when they're picking you up with a sponge off the ground. Wait, what? Sorry. Yep, each one of those, 10,000. Those are 10-ton counterweights. Assembly time! Wait, what? Yeah, Cyanide, yeah, right. Citron. What is happening in this video? What? What? The hell was that? I suddenly want to build cranes. I don't know why. Okay. Zzz. So, oh golly, what's the name of this one again? I forgot. So you have your main boom, there's the mast, and then the center one. What's the center one called? If you want to give me an hour, I can get on and explain this stuff. Maybe when we do another crane stream. Yep. These things right here, the metal that holds those together, those are called pendants. It's basically a strut. A strut with some hinges on it. Hey, Zelnerd. The derrick, that's it. Thank you, Winterside. Yeah, that's the derrick. So you have your mast, you have the derrick, and then you can install the main boom off of that. And if the boom has an extension, it's called a jib. World of Cranes when? World of Cranes? That's a good idea. Not right now, Derek! No, that wasn't me, that was the video. Yep. See how they attach one side and then attach the other? Attach one side, lift it up, attach the other, attach one side, lift it up. And they're using the pulleys on the derrick to lift it up each time. I mean, SpaceX has a very similar crane, dudes. And now they'll lower the derrick, and they'll attach pendants, and then a pulley from the derrick to the main mast. There's a thing to hold the hook windage indicator. That's important. You don't want deflection on the boom at all. And now they'll tighten up the pulleys there between the derrick and the main mast, and there you go. High five! Wait. 3 guys can do that. Oh, yeah, okay, that's the whole point of the video. 3 dudes can put this thing together. That's pretty cool, man. That's pretty neat. I like this one over here. You know why I like it? Because it's bigger. Very nice. That's cool, man. Wait a minute. Hold on. Wait. Goalie, dude. Does that thing move back and forth? Can the, those are stabilizers, right? Those are a stabilizer to make sure that the boom doesn't move too quickly, right? They translate back and forth, right? Yeah, it slides. Cool. Cool, man. Boom stops. Yeah, there you go. It's really cool, man. We should go back to trying to make one of these again. Maybe not today, but it's so you don't boom up too far. Yep. Swing. Does it come in multicolor like the SpaceX one? Well, Jim, yes and no. The cranes, ideally, when you buy them, and come in one color. But you ever as a kid, Jim? Well, maybe not you, but buy 2 Lego kits and then mix and match pieces, and the colors don't come out right. When I say these things are built like a Lego kit, I mean it. They're interchangeable. You could buy parts. You could buy parts for an 11350 and it'll fit on an 11,000. You could buy parts for an 11,000. It'll fit on a 1500. No problem. It's all these boom pieces and derricks and masts and pulleys and counterweights. It's Legos, dude. That's why SpaceX's crane was all a bunch of different colors. It was literally 3. You could buy like 3 Lever 11350s if you're a crane operator. You could buy 3 of them, and then you have enough parts to make a bigger crane, to make the bigger version of the same crane with a power boom and stuff. That boom configuration right there weighed about 100,000 pounds. Oh, that's good. Yeah. It's a little more complicated than that. I know that you need certain adapters. Literally, I'll bet you, goalie, I'll bet you that there's certain pieces you need to make a bigger crane, right? And I'll bet you those pieces are the pieces that cost the most money. Oh yeah, of course there is, Synerd, in every crane's operating manual. Yep. Like, I'll bet you if you want a power boom crane like that 11350, the Franken crane, right, from SpaceX, I'll bet you if you want that, you got to buy certain pieces, but you can use parts from other cranes. You could take like 2 Lever 11,000s, right, and take those pieces, and you can make the power boom if you want to, but you got to buy the power boom parts. I'll bet you that's how that works. They'll upsell you. Liebherr will upsell you. That's the business strategy. If we get enough cranes, we can make Voltron or Mechazilla. You buy an American crane. Manitowoc makes a good crane from what I understand. Different boom. Yep. Hey, nice shirt. Oh, arigato, predominante sama. A Dodge Harmony, Dodge Charger, same engine and frame, just different body. Basically, Jen, yeah. I wonder what the Liebherr floor models look like. Anyway, so let's check out the video coming from NASA Spaceflight. This is from Nick and Sweeney and Boca Chica Gal here. From via NASA Spaceflight. Let's see what's going on. So the chopsticks actually moved. The catcher arms. The catcher arms are actually on a common pivot, and they're kind of L-shaped like this. They actually can pivot left or right, and they moved these things. There they go. Manitowoc makes the largest crawler crane. Excuse me, when Marion Power Shovel Company? You have a Liebherr Lego sitting behind me? Oh, you bought one of those predominant? Oh, geez, no one. Yeah, okay. That $1,500 makes a lot more sense now. Yeah, see? Here, I'll put it to you in 10-second increments, see? Yeah. See, they moved him over to one side. They haven't put it in nom-nom mode yet? No, not yet. I know, Sunheart. I know what you meant. I just got back from Indiana from Orlando. I spent a day at KSC and checked out what they changed. Wow. A little different now, huh? They had both crawlers parked next to each other, too. CT1 and CT2, man. Same two crawler transports we've been using since 1965. Yep. And, Camrad, those were made by Marion Power Shovel Company. That's why I said Marion Power Shovel when. A company that made heavy mining equipment made the crawler transporters. They're basically two diesel electric locomotives sandwiched next to each other with crane tank treads on them. Yeah, it's pretty awesome. Yeah. It's made by a crane company. It's steam shovels, mining shovels, like mining equipment if you want to be technical. I want to see them move vertically. Me too. I wonder how long the CTs will actually be able to operate. Well, Buck, I mean, they don't have very particularly high mileage on them, right? They only move in 3-mile increments. VAB, pad, and back. VAB, pad, and back. But, I mean, regardless, CT1 and CT2 were scheduled to be overhauled as part of the Constellation program. That was under the Constellation program, and when Constellation got canceled, one of them was basically done being overhauled, CT2. And they completely overhauled it after 50 years of use, give or take. 50 years. Well, we could say 50 years. That's fine. After 50 years of use with just routine maintenance. So that should tell you how long those things last. I mean, it's got Alco 216 diesels in it, man. The engines ain't gonna break, that's for sure. CT1 still hasn't been refurbished. They were gonna refurbish both of them under Constellation, but that went out the window. Yep, $30 billion. Yeah, you guessed it. I'm not gonna talk about it. Yep. So CT2 is good to go. It's basically brand new. It could go for another 50 years. They're loud. I bet, dude. I bet. Yeah, right, Rocket? Constellation survives in my head. I will not stop talking about it, Aiden, until NASA has restored that capability. It's true. Hey, what are we doing here? Oh, that's scrap. This thing's got to be junk. Won't they need to overhaul CT1 for SLS, or are they going to use CT2 since they're only hauling 2 rockets a year out to the pads? I'm not sure, Buck. Keep in mind, CT1 can still work. It's just you're going to want to use CT2 because it's basically brand new. They took the whole thing apart. Hey, my pick. Guess what song played in your gym today? I'm going to mute sound just in case of DMCA, but let me hear. It's Chug Jug. Nice. It's a cover of Chug Jug. Look at that. Alright, that's enough. Look at this thing, huh? See how the chopsticks tilt in one direction? Yeah, no problem, of course. Bruh. Bruh. Yeah, look at people just get around on that thing. Yikes. The scale here is messing with my head again, and I know how big this stupid thing is. Still messing with my head. Not gonna lie, I couldn't finish my set when the music started. Sorry. Do you think with all the recent private space stations talk that SpaceX will do a Skylab and put a Starship in LEO to create their own space station? Yeah, sure, why not? They don't even need to leave it there, Lazarus. With the high frequency of flight, you don't even need to do that. Once again, SpaceX's entire thing hinges on high frequency of flight. If they fly a lot, yeah, bro, you don't even need to leave it up there. Just plug a Starship up there and leave it up there for a month, and then, you know, doing laboratory experiments and bring it back down. Because remember, you got to think about it like airplanes, right? You wouldn't just leave an airplane up just flying around. You could. You could, with in-flight refueling, you could just keep it up there, right? With a spacecraft, you could just keep it up there too. But you don't need a dedicated station. Starship could just come right back down. It'll be more like, think like Space Shuttle with Space Hab. So, before the ISS was made, right? And Laz, I'm not sure if you know this. This is just for in case anybody else knows it. Before the ISS was made, what the Space Shuttle will do is, if they wanted a mission that was long duration in space, they would put extra consumables for the shuttle's fuel cells. So the extra consumables for the fuel cells for electrical power and extra oxygen. So the breathy part, humans, dang humans. It was called an extended duration orbiter pallet. It could fit in the payload bay just like anything else. It slots in on a shuttle pallet, right? And then in the rest of the payload bay, they just put an ISS module. Literally an ISS module, and then they just wouldn't release it. They just leave it there, and then it has a tunnel that goes into the shuttle's flight deck. That's it. Or mid-deck, I should say. No airlock needed, no nothing. And the shuttle would stay up there for a couple of weeks, and then it would come back down. Columbia was doing that when it was doing one of those missions when we lost it. I mean, unfortunately, respect the 7, right? But yeah, yes, I don't see why. Starship doesn't even need to make a space station in space. You just send a Starship up there. It can stay up there for a little while. Now, if we want to make a refueling depot, SpaceX supposedly is working on something called a Depot Starship, which I'm pretty sure is more along the lines of what you're describing. Yeah, Depot Starship. Yeah, we don't know what that is. But I'm going to go ahead and guess that it's some kind of gas station, space station, depot thing. The redacted. Yep. Yeah, there you go, Rocket. Oh, by the way, Jay, you have some weird wind down YouTube to watch. Vice Grip posted attempting to get a 25 Studebaker fire truck to run and drive. That's been on his channel before, dude. I'm pretty sure. Flight termination systems right there. I think. Man, this thing's... That's on... Wait, no, that's on Super Heavy. This is on the booster. Ooh. I know, I mean, one of the ways you can tell it's a booster because the pipe's running up the side. Has anything happened since the static fire test? No. The depot from the OIG report lands back on Earth as well. Yeah, that's true, yep. Thomas, that's why the first thing that I said was Starship doesn't even need to do that. Just, it's, dude, it's kind of smart. You know, just leave the depot Starship up there for a little while. Doesn't need people on it, just stores fuel. All you need is some electrical power, so it basically works like the X-37, right? X-37, Starship style, right? Right. So you just do that. And then you don't really have to worry about burdening yourself with the maintenance cost of a space station. Oh, my space station isn't doing something that I want. Okay, bring it back down, land it, and fix it, and then send it back up again. That's what they wanted to do with the space shuttle. That was the idea. They never ended up doing it, though. A single pressurized volume in the Starship Labs. I believe we've done the math out for usable payload space. It's about 1,000 cubic meters, so way bigger than my apartment. My apartment could fit inside of it 3 or 4 times over. We're after a gimbal mount. Wait, what's this gimbal attached to? Yeah, it's just a big U-joint. What do you think a gimbal is, Entropy? It's the same thing. Big U-joint. What's Friday Night Racing look like? That's on the crush stand. Interesting, interesting. Yeah, Solar, exactly. I bet you we will, Aiden, and I'll bet you NASA spaceflight won't blank his face out. Unless he's okay with it. That's the real big thing. For some reason, that makes me feel the scale so much more. This thing's huge, dude. Yep. Freaking coral reef. How about sometime in the future, Blue Origin has that orbital reef space station with Boeing, and SpaceX shows up in a starship and just flies around the station. Eileen Collins did that with Mir one time. One of the first shuttle Mir missions. The shuttle needed to inspect the Mir space station, so they wanted to inspect it before they docked to the station, right? So Mir is floating around. Eileen Collins flew the shuttle up to Mir and literally did loops. Eileen Collins buzzed a space station with the space shuttle. That's a true story. Yep. Yep. No, buzzing the tower? No. Buzzing the space station. Yes. Ooh, savage rocket kind. Oof. I've never been, Corsi. No, I've never been down there. Maybe one of these days when Das heads down there, I'll hitch a ride or something. I don't know. Or I'll just show up in Tough Enough and see what happens. I don't know. What's buzzing? Flying near. You buzz the tower, you fly near the towers, Ensign. I know, Rocky Guy. I know you're just throwing shade. It's all good. Yeah, Rocky Guy, we were talking about it, dude. It's such a strange fault tree, that one. That's such a strange fault tree, dude. I don't think that's the engineering, man. I really don't. Something weird is going on there. What really throws me for a curveball with that Starliner stuff, we'll jump back into this in a second. Hey, Juno, 52-month resub. What really throws me for a curveball with Starliner is that they took the crappy valves out, right? And they put new valves in, and then they tested it again, and it rusted out the new valves as well. That's the one that gets me. That's very strange. Dude, you know what that tells me, Rocket Guy? The problem might not even be with the valves. It could be something upstream that's not working correctly, that's screwing the valves up, which is just, Oh. Yeah, Cameron, just get perms from the moderators in chat. Yeah. Rocket Guy and I were talking about Starliner. When was this revealed? During the last presser, Thomas. During the last presser, dude. They unstuck most of the valves, then they changed 4 out, and the 4 that they changed out were the most corroded. They put new valves back in, and those ones rusted out too. Ugh. That makes this so much more complicated, dude. Because that means your valves are a symptom. They're not the problem. That's like saying, oh, I'm sneezing, so, I better have anti-sneezing medication instead of anti-cold medication, right? Like, that's not, the sneezing is just a symptom. That's not the problem. What time is racing? Only asking because I got work at 7 a.m. It's 11. Judo. Racing tonight is going to begin at 11 p.m. Eastern time, so that's plus 5 to you, so 4 or 5 a.m., something like that. You could wake up if you wanted to and race with us. Why are they rusting? Jawa, they're rusting because nitric acid is building up inside of the valves. Nitric acid was formed when nitrogen tetroxide ate through the Teflon coating in the valves that keep them watertight, so to speak. And the valve, yeah, Soler, they assumed that the valves were working as intended. They worked on OFT1. They worked on OFT1. They worked on the pad abort system. Those were real service modules. It's a strange one, dude. And I highly, I know what people were saying, like, oh, well, OFT1 was launched in the winter, low humidity in Florida. And then, the abort test was in White Sands, where there's also low humidity because it's the desert. That implies that they made the capsule and the service module outside, which is probably some of the stupidest things I've ever heard. They made all the service modules in the same spot. They were all made at the C3PF at KSC. They were all made in the same spot. So some of the service modules that this place made, that the C3PF made, that the Starliner factory made, worked perfectly with no corrosion in the valves, and this one didn't. It's very strange. It's a very strange problem. That's right, Dead Crew. Yep. Hey, Reagan, what's going on? Long time no see. Yeah, Rocket Guy. I'll give you 3 guesses who. Somebody implied that in an article that, atmospheric humidity conditions could have something to do with why the inside of a pressurized closed system can corrode. Just end it. You guys already know. All right. Yep. Is the MS-18 docking, Jazos? We can go check that out, dude, if you want. It was me! I'm like, dude, what are you talking about? And then during that presser, Vulcan, some people were like, well, is the thing watertight? How do you prevent water from getting in? I'm like, water didn't get into it. What? Are you guys even listening? Like, Jesus. They're like, well, how did the water get in there in the first place? We're not dealing with water. We're dealing with NTO decomposition with Teflon making nitric acid inside of the valves. Well, how did the water get in there? What? Stop this! Stop it! Stop that! That was literally at press conference. I'm like, what are you guys talking about? Stop it! These questions don't even make sense. Stop it with the water. Yeah, that's true, Encode. They do ask questions just so they can cite it in their article. That's why we get redundant questions. That's something that I struggle with because as a space fan, I want to know more about it. So hearing redundant questions and hearing NASA just repeat itself is very annoying. But I understand why people do it. I get it. I know already, W. It was mentioned like 30 seconds before you said that. Somebody else mentioned it. Yeah, I got it. Thank you. There's one of the covers. At least I think that's what that is. Yeah, booster cover. This is some wood with a pink stripe. It's pink. That's cool. No, those are they already said it on here, but those are ties for the crane. They'll put these things down, and they'll lay them down kind of horizontally, like if you took a bunch of Jenga blocks and laid them down, and then they'll drive the crane with the treads up on the ties to help disperse the load. They do that to make sure that the crane, when it goes to lift something up, if it's heavy, you're gonna crunch the wood and not crunch the pavement. They do that to protect the ground because it spreads the load over a bigger surface area. Yeah, Solar, I guess they can't. I don't know. I mean, Sea Vulcan Streaming's link. Is this the link of the launch that you told me about right after somebody else told me about it?
And
You know, the more you tell me about it, the less I'm going to put it on, right? In case you haven't figured that one out. It does, yeah. Spaceship, it needs to vent. Yeah, right. Speaking of Artemis 1, sunset launch on a Saturday would be literally the best thing to happen in the history of ever. Low probability of that happening, but maybe. Kind of have a 1 in 7 on that one, don't you? Yeah, Caveman, it would, but then the journalists would write about how they were jerks. That's the thing with journalists, man. You got to just kind of sit there and answer it, no matter how stupid the question is. Yeah, Vulcan, tell me when you're going. Seriously, I'll go with you. Take a weekend, dude. I'll fly down there and then we'll take a drive. Or I'll just drive down there and then we'll take another drive. That could work too. Vulcan, I would ask if you can drive stick, but yeah. You want to drive tough enough around? Dude, I'm down to try and do it sometime this winter. Okay. I mean, maybe we'll go down for the orbital flight test, dude, if that's what we want to do. But I only have 2 seats in the truck. That's the thing. So it's just got to be me. It's got to be me and you. Somebody, or we could convoy it with somebody. Look at this thing. Is this a? Let me take a look. Yeah. See, this is all testing equipment. What are they gonna do with this thing? I won't be going to the orbital flight test. I'll be watching that with a friend here in Florida. All right. Oh, they're putting this on the dynamic test stand. Huh. Okay. Ooh, they gonna crunch this thing? See my big message for my thoughts on Booster 2.1. It's most likely to test the 3 center engine mounts on a thrust dome mounted inside a booster aft skirt. This wouldn't see them throw away a 13 engine thrust puck, which are way more expensive than the tri one they have on Booster 2.1. Oh. I'm sorry, Jim. I'm afraid I can't do that. Okay, Vulcan. Okay.
Discovery, go at throttle.
I have vacation time around the SLS launch, so might buy you beer down there. Oh, I'm going to that. We're going to Artemis 1. Yeah. Yeah, we're doing that. Even if that means me taking a day off to stream to make sure that Tough Enough is good to go. Even if I have to, even if it's snowing up here and I have to winterize the dang thing, I'll still do it. This guy's moving some rings around here. Oh, nice. You got a little bit of camera shake action going on here. Route 154 to Artemis 1. I've always said, Thomas, that Route 154 was just a primer, dude. I would love to stream the road trip going down. You know? Rings here. Hopefully, Aiden, yeah. Oh, here's the start of the new high bay here. It looks like this is using a slightly different construction than the other bays here. The other bays they made in prefabricated segments, but then again, these are being made in some prefabricated segments as well. You ever need a ride from the airport in Texas for the winter? All right, Snake. Yeah, I got you, man. I got you. Hey, Tech, what's going on? Yep. Lift it up. Move it into position. Not a lot. You okay? I'm good. I'm good today. I still feel kind of like crap, but I'm just putting on my brave face, you know. That is a big wrench. Wow. That's a freaking huge wrench. You need a huge wrench to turn those huge nuts, boy. Yeah, Thomas, that would be actually kind of cool. These are adult Legos right here. Actually, it's adult Meccano or Erector set. MS-18 is docking. Yeah. Twins, Basil. Twins. Twins, Basil. Oh. Oh. Oh, it's got the cover on. Oh, that reminds me of a shuttle engine. That makes me so happy. Hello. Bro, that is awesome. You guys remember at the beginning of Space News when we were looking at those RS-25s? Yeah, you know how you saw how complicated that is? That's more complicated. There's more pipes. Are you American? I am from... you're from Finland? Blom, Eve Paive. Terve. Yeah. It's interesting that we are starting to see the refinement of Starship. Yeah, that dude, that looks... It's got the freaking cover on it, man. No Vito, Luis. No Vito. No Satana. Played too much My Summer Car. That's a different language. Nightcore NSF. Let's hear it again. Yeah. He's like the you know, like Eurobeat. Night of Fire. It is Pythos, yes. Night of Fire. Sorry. Anyway. We have one more thing to watch here.
And let's proceed with the fly.
I don't know if you guys are interested in live views of the International Space Station. Or a spaceship that we watched launch 2 days ago. Or was that yesterday? No, 2 days ago. Docked to the ISS.
Coming up on the 200-meter mark.
Who's Mark?
Nearing the end of the fly-around.
Oh, we're way behind.
It's propulsion,
All right, let's
thermal.
go over here. We must fast forward. Prepare to fast forward. Fast forward. Fast forwarding, sir.
Nearing the end of the fly-around.
Switch to teleview.
Progress soon to position itself directly behind the Zvezda service module at a distance of 150 meters for that brief period of station keeping.
So the range is 200 meters and range weight is
Привет,
-0.16.
Progress. Как
And
дела?
the size of the Progress is about...
There we go. Now we're caught up.
The size is about a square.
Now it's just station keeping here till...
You can see engine firings on the Progress. Once
really-
again, fine-tuning its path for its period of station keeping.
I really appreciate what's being shown right now. Get it off. Get it off me, man. Why do you gotta put it? Why you gotta frame the shot where I am? Why you gotta do that, NASA? Stop it. So you see the spacecraft. It's using its thrusters to basically get lined up. Here. Oh, okay. This is blue. All right. Now I know what you're saying. Like firing two thrusters like this, it's not going to do anything, right? Well, actually, one of those thrusters is here and the other one's here. If that's the front of the spacecraft, so firing those thrusters, that's pitch control. When you see it firing two up and down at the same time, that means it's pitching in one direction. Right now, it doesn't look like it's moving so much because the ISS is right here, and Progress basically came at the station like this, and what it's doing is it's rotating down underneath, or no, well, actually, it's the reverse. It came up to the station like this, and now it's rotating out and behind the space station, and then it's going to dock to the back of the space station right there. That was that view that you just saw right there. Glad Rob Navius is still around. I hope he commentates parts of Artemis 1. They should bring George Diller back for that.
Approaching the station keeping point, not quite there, just a moment or two from now. The unpiloted Progress doing exactly what it was programmed
thrusters.
to do.
Okay, we're aiming right here.
Just about 200 meters separating Progress from the station. You see just to the upper right of the center of the crosshairs, that's the docking port of the Zvezda service module where the Progress soon will link up to.
There's two Soyuz. Or actually, no, there's a Soyuz and a Progress capsule. Another one that's kind of like this.
So the range is
What's that? Corn and Wine. My husband said you don't watch EJ, you consume EJ. I think that's a really good point. This has been a good learning experience for all of us. Sorry I don't sub. My husband watches you endlessly. Oh, Corn, I don't care. It's all right. It's really fine. Like, seriously. You know what drives me with this kind of stuff? The fact that getting people interested is what I'm really after. Yes, the sub count's great, and that's great for my wallet. I understand, but that... I mean, don't get me wrong. I'm not going to sit here and say that if the sub count was double, that'd be really great, right? You don't worry about it. But someone's probably going to gift you a sub, right? Yep. Okay, I already said it. But hey, don't worry about it. It's fine. I'm just flattered that people will give me the time of day. That's what makes the stream good, and that's my defining principle. I don't say stuff to get subs. I say stuff to get people interested in space. Subs are not expected. Nothing is expected. But that doesn't mean they don't appreciate it either. But yeah, don't worry about it. It's all good. But yeah, that's great. I'm really happy. I'm really happy that I can make someone's day better. I mean, sometimes I had bad days. I had a bad day yesterday. But if I can make your day better, then mission accomplished. I love you. You're amazing. Thank you. Okay. And B-Money gifted a sub to Blackbird, and Solar gave you a sub, so there you go. Now you get some sweet rocket emotes. You are in a position to demand nothing.
Everything remains on track. The Progress is in the neighborhood of the International Space Station, soon to complete its fly-around.
KSP will be after the docking. After this thing docks up.
Anton. Please issue.
And station keeping has begun.
Unintelligent.
The fly-around now complete. This should be very
After this docks, we're going to watch the
Russian
KSP2
flight
video, and then
controllers
it's
now
time
assessing
for
the
cable, yeah.
of the forward docking probe with the aft port of the Zvezda service module.
Thanks, Dama. I appreciate it, man.
Copy. Are we confirm approach? And I'm turning off operation. Operation is off. We are accelerating. All right, and then move to page 23, monitor automated automated approach.
Yeah, this is live right now, Platinum.
And
That's why
final
we're watching
approach
it.
is now underway.
I know, Hibbert. Yeah.
This will be a slow and methodical maneuver by the Progress, ever so slow to move in at ultimately a rate of about 1/10 of a meter per second for contact and capture of the docking port.
Range is 160. And the range rate is unintelligible minus 28. And the target is in the center of the periscope. Copy and copy.
Okay, so a little bit of a breakdown of the information here. This over here, KURS 1 indicates that the automatic docking system is working. KURS, that's what KYPC means. That's KURS in Russian. This is I think that's that's roll rates and translation rates right there. So if you're turning, right, in one direction or another, I think these ones might be translation. I think these ones are roll down here. Over here, you have, these are your velocities in meters a second right here. Well, this one is distance. That's kilometers, and that's meters a second. So it's 0.116 kilometers away. So you're 116 meters away, and I think it's not going very fast. I think it was like less than a meter a second. OC are the rates. Gotcha, Rocket Guy. So the stuff that you got to pay attention to is this stuff down here. So we're traveling at 0.56 meters a second. So that's like, for the feet per second, if you want to know that, that's like a little bit over 2 feet a second, something like that. And it's 0.94 kilometers away. So we're 90 meters out from the station. So about 300 feet. Once again, the KURS automated system is flying this thing in. No one's flying it, but Anton Shkaplerov, the commander of the Soyuz MS-19, is up there. Who's up there with him right now? Anton is up there, and I think it's Peter Dubrov and Oleg Novitsky, unless they came down. One of them came down. I forget who's up there. I know that Russian Mission Control is talking to Shkap, talking to Anton, and he is monitoring it inside of this module right here. If something goes wrong with the KURS system, he'll assume manual control and pilot the thing in from the ISS manually. Yep, there's the cupola right there, attached to Node 3. That's the shutters are all closed though right now. This is this is Nauka right there, the Russian science module. That was just added a little bit earlier this year, which is pretty sweet.
Progress from the station.
So the range is about 55 meters based on the
Mark Van He, Peter Dubrov, Toma Piskay, Megan MacArthur, Shane
crosshairs
Kimbrough,
are
Aki
aligned.
Hoshide, Anton.
We copy.
So Peter stayed up there. Oleg came back down. He came back down with the crew from the challenge. So Peter and Anton are up there with Mark. Peter and Anton are 2 Russian cosmonauts. Mark is a NASA astronaut that flew up there on a Soyuz. Let's see. Here's our current track. This line right here is the ISS current orbit. Over here is the next orbit, the line that was in front of it. The ISS is currently over Chile right now. Actually, a little bit to the west of Chile. You can see the spaceship and the ISS right there. This is your day-night cycle right here. Keep in mind, this image is super freaking distorted because you're trying to take a globe, right, and impose it on a
meters now
rectangle.
separating progress.
So you get a little bit of a stretched
We're waiting
image.
to reacquire our downlink signal through the tracking and data relay satellite system. This view from a balcony camera in the Russian Mission Control Center in Korolyov outside Moscow. Russian flight controllers in contact with cosmonauts Anton Shkaplerov and Pyotr Dubrov inside the Zvezda service module, which will be the port of call just a few minutes from now for the Progress 79 cargo craft.
The docking node is about 2 squares, and the range is approximately 140 meters.
So Up here, a little bit of info about Russian mission control. This is in Star City, Russia, which is in the Moscow province. It's basically right outside of Moscow. All the stuff up here, up at the very top, is so RCMKC is Russian segment ISS, and then it shows all the modules in parentheses there that's attached to the ISS, all the Russian segment stuff. So you have Zarya, Zvezda, you have Poisk, Nauka, MS-18, Progress MS-17 or MS-16 or something like that. And then this Progress capsule is actually over off on the right side because it's not docked to anything. It showed all the stuff that was all the Russian stuff that's docked to the space station. Right now, this thing is going at 0.13 meters a second, and it's about 38 meters. The Kur's automated docking system is still working correctly here. KYPC right there, or Kurs in Russian, is the automated docking system. You have your body roll rates right here. This is in degrees here, so that's like, it shows if the thing is moving left to right or roll. It's basically yaw, pitch, and roll. What you're seeing here is the very, very back of the ISS. This is the aft port on this Zvezda module, which is the service module for the ISS. It's a service and propulsion system. It's docking to the very back of it. What, Jim? Maybe Cajun. Yeah. Okay. So another interesting thing to note is that this Soyuz Progress is kind of, the ISS is like this, and it's kind of coming in tilted. It's coming in at like 45 degrees roll left. That's because Soyuz's docking system it's a slot system, so it kind of works like twisting a bottle cap onto the top of a bottle. So it comes in kind of sideways, and then it'll soft capture, and then when they bring it in, it'll kind of turn a little bit and lock into position. You can see the slot marks in the docking ports right there where it moves. It's not very much. That was over exaggerated, but it's just a teeny weeny bit. It'll kind of lock into position.
I see everything very clearly.
They rotate it so they can basically locate the latches correctly.
The size of the target.
Oh, cores, yeah,
cores,
not cores. Why are they still using a black and white camera? Judo, this is one Progress is expendable. Why do you need it? Two, this is literally like the flight camera, because the Russians don't give a frick, dude. NASA wouldn't show something like this, you know. NASA would show you the color cameras, right? The Russians just said, nah, they won't live view. We pipe in picture of Progress, picture of what Progress sees. I mean, they don't care. Use a black and white camera. Actually, this probably isn't black and white, dude. I'll bet you it's infrared.
Target.
I'll bet you it's IR.
I see the target. And there is a little bit of a 5-degree roll. The target is in the center of the periscope, and the crosshairs are aligned.
Rocket Guy says that you use black and white for high contrast to dock with the fiduciaries. Nice. It's old anyway. It's an old design.
The size of the target, the angular size of the target is about 2 squares.
Yeah, there you go. That's why, I mean, Rocket Guy, do you think this is infrared? It could be IR.
The center of the target is a little bit off to the right by 1 degree. We copy.
So, that's SSVP. That's the docking port. That's the name of the docking port right there. So, right now, we're moving at
coming up on the 10-meter mark.
1-2 meters a second.
The target is about 2.5 squares. We just passed this mark. We copy.
They're talking about this. They're making sure that Kurz is on the bullseye.
Closing at the expected rate of about 1/10 of a meter per second.
Meters.
1/10 of a meter a second. There it is.
The target is in the center.
Okay. Stand by for booping.
5 meters now.
Drop the quick save. Cajun.
Capture.
The range is 1 meter. Copy.
So this thing is doing this automatically. It's an automated docking. This is an unmanned resupply ship. Okay. So 5 meters. 12 centimeters a second. So
The crosshairs are aligned.
we're about a
and
third
the
of a
target
feet
is
per
in the
second
center.
here, and
Contact confirmed.
Mechanical contact.
And capture confirmed.
Okay.
At 8:31 p.m. Central Time, 9:31 p.m. Eastern Time.
And
As Progress and the
snoot
International
has been
Space
booped.
Station flew 258 miles over Argentina, just south of Buenos Aires.
this is
Now,
live, yes.
please deactivate Toru on our go after probe retraction. Copy.
The docking probe on the Progress now retracting. That will bring the Progress docking surface.
Now turn on the
flush
boosters.
with the aft port of the Zvezda service module to initiate the closing of the hooks. It doesn't get much smoother than that. A flawless ride from launch pad in Baikonur to docking at the International Space Station. Contact and capture docking occurring at 8:31 p.m. Central Time, 9:31 p.m. Eastern Time.
The boop has been snooped.
Another 3 tons of food, fuel, and supplies being delivered to the International Space Station.
You can see up in the top right, is that, I think that's local time. That's Moscow time. I think, it's 4:30 in the morning over there. Do a flip! Yeah. See if we get an external view here. So note that there's no 1 flashing next to the curse. That means that it's shut off. So the automated docking system isn't needed. They shut it off, I'm pretty sure, or it's disarmed. Could be enabled, but not disarmed. They shut the 1 off there. This thing stopped at 4 meters from target, but whatever. So up here, Russian segment, International Space Station, Zarya, Zvezda, Poisk, Rasvet, Progress MS-17.
The docking probe about
Nauka,
halfway now
Soyuz
in its
MS-19,
maneuver
and
to
then Progress
drive the
MS-18.
2 docking
This will
surfaces
move over here in a second
of the Progress and
when
the
there's hard
Zvezda
capture.
service module flush against one another. That will initiate the closing of the hooks to form a hard mate.
Yeah, see, they're gonna retract the docking probe. It's gonna bring the 2 docking ports together, and then they'll latch it and hook it into position. You can see a diagram of the SSVP working up there. See this conic section right there? That's what they use to locate the docking port, and that's actually on a worm gear. It's on a worm gear, and it actually retracts, and it pulls the 2 docking ports together. See that? There's a locator here, and basically a threaded rod right
the
there.
completion of the retraction of the forward docking probe on the Progress.
Actually have a model
Again,
of it going right
the
there.
launch
See?
of this
The hooks
resupply
are
ship, the unpiloted Progress
pull it in,
79, occurred on
and then
Wednesday
it'll
night U.S.
lock
time,
together.
early Thursday morning at the Baikonur Cosmodrome in Kazakhstan on a Soyuz 2.1A booster.
I don't.
An
What do you mean,
8-minute,
Cajun?
45-second ride to its preliminary orbit.
A day,
Progress separated from the upper stage, the 3rd stage of the Soyuz booster, deployed its solar arrays and navigational antennas, and began what turned out to be a perfect 2-day journey for its docking to the aft port of the Zvezda service module, just standing by now for the closing of the hooks to form a hard mate between Progress and Zvezda.
This kind of weird shape that's around Russia shows the range of their ground tracking stations over there. That's basically when they have direct ground communication. Everything else is handled through NASA's tracking data and relay systems. But the Russians can also use their system as actually, I think the Russians have a tracking system, but I only think it works at high altitudes, but I could be wrong on that. They could have Molino orbits for tracking, but I forget.
And the hooks are now driving.
Yep.
This will take just a couple of minutes. A hard mate will be formed between Progress and the Zvezda service module.
We should see an indicator of hook latching up here. I've never seen this view before. This shows the progress of the docking system. Like, it's almost done. They almost drove the hooks in. Once it hooks in, see this kind of little area here? They have to make sure that they pressurize that area correctly. Hooks are closed. There it is. See it pop up? It popped up on the timeline right here. I can't really read what that says. Who is it, Ray? Randall, you know how every circle of friends has that one guy that's kind of there? He's a good dude, but he's also a jerk. That's it, Mana. Yeah, I don't think he's here right now, Randall, but the progress of the docking system on the progress capsule. Allow myself to introduce myself. You know that the hooks are closed right here, and I know that's what that means, because up here, if you look back a little ways, let's back it up a second. Right? See that?
Standing by now
see?
For the closing
Progress,
of the hooks to form a hard mate.
MS-18 moved over there. See that? The hooks are closed. And then, see all those extra steps? They moved it over here. Once again, up here, RS ISS, Russian segment of the International Space Station. Zarya, Zvezda, Poisk, Rasvet, Progress MS-17, Nauka, Soyuz MS-19, Progress MS-18. The cool thing is that this is the order that this stuff was sent up from.
Mission Control Houston. The hooks are now confirmed to be closed between Progress and the Zvezda service module, so we now have a hard mate between the newly arrived cargo ship and the Zvezda service module. Cosmonauts Anton Shkaplerov and Pyotr Dubrov will conduct leak checks at the docking interface between Zvezda and Progress to ensure that we have an airtight mate between the two vehicles before they open the hatch later this evening to begin to unload some of the more time-critical cargo on board the Progress resupply ship. Almost 3 tons of food, fuel, and supplies now in the process of having been delivered to the international outpost. So Progress completed a perfect 2-day rendezvous from its launch in the Baikonur Cosmodrome in Kazakhstan to arrive at the International Space Station, docking occurring at 8:31 p.m. Central Time, 9:31 p.m. Eastern Time, as the two vehicles flew 258 miles over Argentina, just south of Buenos Aires. With that, we'll wrap up our coverage with one programming note. It's not over at the station. Multiple vehicles coming and going, and next up in the queue, the Crew 3 launch of Commander Raja Chari, pilot Tom Marshburn, Mission Specialist Matthias Maurer of the European Space Agency, and Mission Specialist Caleb Barron of NASA, as they ride the Crew Dragon Endurance from Launch Pad 39A at the Kennedy Space Center to the International Space Station. Our coverage tomorrow night begins at 10 p.m. Eastern Time, 9 p.m. Central Time, with docking scheduled on Halloween on Sunday, October 31st.
We'll be here for all of that.
2:21 and 7 seconds a.m. Eastern Time, 1:21 and 7 seconds a.m. Central Time on Sunday morning. Reviews of preparations for launch are continuing down at the Kennedy Space Center. Weather permitting, the launch will take place in the wee hours of Sunday morning, bringing 4 new crew members to join the Expedition 66 crew on the International Outpost. For now, that will wrap up our coverage. Progress 79, the cargo ship, having arrived at the International Space Station, docking was by the book, no issues reported, and new supplies are now about to be brought on board the International Complex. So with that, we'll call it an evening. We hope you have a great weekend. Don't forget to tune in for our coverage of the Crew 3 launch. In the meantime, a good Friday night to you all from Mission Control in Houston.
Manual controls.
I wish they'd just let the lady talk. All right, guys. Well, it's pretty good. Hey, that's pretty good. Have you seen the Expedition 66 patch? They based it on the Route 66 highway sign. Yeah, I just saw it a second ago. That's cool. Predominant, we usually start at 11 p.m. Eastern Time. That's when I try to target the start time for Hunt the Streamer. Move that forward or backwards by 4 hours. So, so 11 p.m. would be 11 a.m. for you, give or take. No, it's gonna be in the morning, man. Yeah, so it would be like, I think it's 8 a.m. I think it's hard to. I know that you're give or take about 12 hours ahead, right? Like give or take, but that fluctuates with daylight savings, and we switch the clocks this time around. So we change our clocks this